I would like to welcome you all to the 13th International Conference on Business Information Security. On behalf of the organizing committee, my name is Neven Izrakovic. I'm an assistant professor here at the Faculty of Information Technology and the head of the Laboratory for Blockchain Technologies at Belgrade Metropolitan University. Today we have a couple of sessions. One will be live, one will be online, but first of all, I would like to invite Professor Miroslava Raspopovic-Milic, our Dean of the Faculty of Information Technology, to open the conference, and then we'll start with our two keynote sessions.
Welcome everybody to Metropolitan University. Warm greetings, because outside is so cold. So hopefully you guys can have a very productive meeting today. This year's conference, as usual, is a very important topic to Metropolitan University. As Nemanja said, it's a 13th international conference. However, this conference actually started as a small gathering local group here in Serbia, and our initial motivation was to start thinking about information security and build good quality academic programs in information technology, software engineering that actually deal with the topic that is information security. Today we have both bachelor degrees and master degrees programs that include in their curricula program that deal with information security. Our new programs in IT and software engineering, we have introduced several new courses that are both in cryptography, crypto technology, and even in blockchain. And we also have a Master of Science that is a cybersecurity program and that deals with very advanced topics. We follow IEEE and ACM recommendations, the latest one for the cybersecurity, and this is the reason why we like to gather experts in this field so we can hear from you guys what's new, what's active, and we use the information that we hear to try to improve our programs. So without further ado, again, welcome to Metropolitan University, and I wish you a successful work in this meeting.
Good morning. Welcome to my session, Federated Machine Learning and Blockchain. Okay. So this is the outline of my presentation. Introduction to Federated Learning, challenges in Federated Learning, blockchain-enabled Federated Learning, and use cases for blockchain-enabled Federated Learning. I have split the use cases into two aspects. One is blockchain for FL, how blockchain can help for the Federated Learning. And another aspect is FL for blockchain, how Federated Learning can help blockchain. These are the two aspects of case studies I am introducing. Right. So let's see that what is Federated Learning. So you know machine learning. Machine learnings are usually developed to solve the complex problem with the help of large available data. It is different from traditional programming approach of solving the problem. And traditional programming approach, we develop programs were rule based. That means if what should do the program, suppose X event is happening, some Y event is happening like this. Fully exclusive rule based programming we do. Whether in machine learning, we don't rely on rule based. You cannot capture all the rules for any complex systems to develop your problem solving programs. So we train the program, we develop a model that is called machine learning model that will that can handle any situation which is not at all exposed earlier. So that is through training by the data. We have to give a lot of data to train the model, and you have to expose the model to experience all the scenario. So that is a machine learning model. So traditionally machine learnings are developed in single computer. I will take my data, I will feed the data, I will train the model, and I will develop the model and I will deploy it. So that is the traditional approach of deployment of machine learning model, whereas federated learning is different from that, because now we are in the big data era. We have a lot of data. So training machine learning model using large amount of data in a single machine is very, very complex. And also the single machine may not be able to handle the complexity of training. Right? It is huge data. So millions of the data we have to train them in using single machine in a single computer. It is very complex. It will take a lot of time. And another aspect of traditional machine learning is we have now a lot of complex problems. To solve those complex problems, we need a very complex machine learning model. Developing such a very big complex model using a single machine is very, very challenging. To avoid these two drawbacks, federated learnings are introduced. So on the federated learning, we are not going to be train the model in single center place. We do distributed training. So we develop machine learning model and distributed manner. That means we use development of model, the locally available data in various clients. The clients, they use their own data. They will train the model. They send the trained model to the central server. In central server, we aggregate all the trained model from the client. We'll make global model. So such a global model is exposed to lot of data from lot of client. It is very robust one. That is the idea of federated learning. So this mechanism, you can see that we have a lot of data owners, owner A, owner B, owner C. They train the machine learning model in the locally with their data, and they send the model to the central server, where the central server aggregate all these model communicated by the clients, and it is making a global model. So that global model is very robust one, because it is experienced a lot of the data from a lot of the clients, right? So you see, the global model is again communicated to all the local server to utilize that. So that is the fantastic of federated learning. We can develop very robust model by getting data from all over the globe, from all over the clients. And another aspect of this federated learning is data security and privacy. See, I want to make my model global model. I want data from all over globe, but people are not ready to share the data. They are reluctant to give the data. It is a matter of privacy, right? So that privacy issue also we can handle using federated learning. So I am not going to get data from anybody. Just I am giving you my model. Okay, you take this model, train locally with your data. You just share the trained model. That's enough for me. I am not interested in your data. That is what the approach we are doing under federated learning. So you see the data privacy is maintained here. So people are ready to train by the model, but they are not ready to share the data, right? So that is another aspect of federated learning, right? This is very, very useful, especially medical applications. Medical applications, you know that you have to develop a robust model by getting data from all over across the globe. For example, if you are interested to develop a machine learning model for COVID-19 diagnosis, you have to get the data from all over globe. Then only your model is robust one. But people will not give their data. So what we can do? We can apply this federated learning. We can ask them to train your the model with your data locally. I don't want your data. Just to set the model to me. I will take all your trained model, aggregate, and make a global model. That model will be more robust. It can diagnose very accurately the COVID-19, right? So that is the approach, right? Alright. So challenges in federated learning. So we have these are listed challenges: data imbalance, system heterogeneity, privacy concern, expensive communications, resource allocation, and statistical heterogeneity. So data imbalance is different clients, they have different amount of data while they are training the model. That is the issue. And system heterogeneity is different client. I am asking different client to train the model. They have different system configurations. Some of the client may have very good system, some of them not very good system. That is different. So that is another system heterogeneity issue. And privacy. Again, when they train the model, they are communicating to us. That time maybe some attack happened. That is the privacy concern. And there are a lot of communications happening between the server and clients that should be handled. Then resource allocations. Okay, so how many computer I have to use for distributed training? That and what are the resources I require? This resource allocation is another issue. And statistical heterogeneity. The data available in different clients are statistically different. They have different distributions. So having such a different distribution data and training the model and aggregating the model is another challenge, right? So among these challenges, we are only concerned about one of the challenges, privacy concern, where we are bringing the blockchain into this to solve this privacy concern, right? So we will see that one of the challenge only privacy concern. Okay, in the privacy concern, we have to solve the issue of how I share the data or the trained model securely to the server. That is the issue. So for that, we are bringing to blockchain into the picture, right? See, this blockchain is decentralized and immutable, and also it's distributed in nature. So federated learning also distributed learning. so both will match each other. That is the idea of combining blockchain and federated learning. By basically both are distributed system, easily I can integrate. That is the core idea, right? And blockchain is for immutability, data transparency and security, whereas machine learning or deep learning, federated learnings are to make some application using deep learning models. So these two we can combine, we can develop a secured distributed machine learning models for robust diagnosis or robust problem solving. Robust. Right. So privacy concern, we have a lot of the privacy concern, that is data poisoning attack and model poisoning attack. This is the two attacks we can expect in any federated machine learning. Federated machine learning, I am asking all my clients to train the model and send to me. Well, while they are sending the model to me, to the server, there may be attacks. That attacks are called data poisoning attack or model poisoning attack. I may, under data poisoning attack, people may change the data content of the local server or local client such that they will generate wrong model. Whereas in the case of model poisoning attack, the attacker may be going to disturb or change the model which is trained model they are communicated to server. These are two approaches. So these two problems can be solved by blockchain. That is the key idea, right? So blockchain for FL. The use cases we will get into that now, right? So first use case, cognitive computing in Industry 4.0 networks. Right? This is the use case where we are going to use blockchain for FL. Right? So what is cognitive computing? Cognitive is a process, mental process, that is having various sub-processes. That means sense, perceive, understand, make decision, act. This is the cycle called cognitive cycle that we do in our system of brain. Whatever you want to do, you first sense what is that, you understand what is that. Then you do make decision, okay, this is what, this, I have to do this, like this, you make decision, then you will act. This is what we do, whatever activity we do. For example, I am interested to walk, I have to sense this is the path, yes. I have to make now move, decision making. So this is what we do in any activity. Our brain is relies on this cognitive cycle. So same concept of brain activity or cognitive cycle can be implemented in Industry 4. I can import this cognitive cycle model to all the machineries in Industry 4.0. So what is the advantage? Actually, we are importing our brain system into machine, our human intelligence into machine. That is the idea of importing cognitive computing into the machines. So now the machines are self-decision making units because we just implemented software how our brain system is working. That is called cognitive computing. So these cognitive computing is very famous in Industry 4.0 because they want to make all machineries to self-decision making unit under 4.0, right? So that for that, you know that this understanding the cognitive cycle part, sensing, understanding, decision making. On that, this understanding and decision making is based on machine learning or deep learning. That is where the machine learning and deep learning is coming into cognitive computing of Industry 4.0. So people are adopting this intelligent cognitive computing techniques in machineries in Industry 4.0. But as usual, we have the issue of poisoning attack. Right? So this poisoning attack will affect our machine learning model developed under the machinery, and for that we can use blockchain. That is the area. Okay. So what is the advantage of blockchain for using security aspect or privacy aspect under federated learning, right? So first one, usually under federated learning, one server acts as a controller, other will be client. That mechanism or that approach we are changing under this. Here we make distributed server, distributed one, that is any device will be act as a server, central server, and based on selection mechanism, which solve the problem of single point of failure. In federated learning, we have the problem of single point failure because the single server is aggregating all the model. That server is supposed failure, entire system fail, right? So to avoid that, blockchain technology already distributed mechanism, it is distributed approach. So we can select on Hadar the server and around, then we can use at a time one node as a server. That is the mechanism we can apply that can solve the single point of failure issues in federated learning. That is the key advantage of blockchain based approach for federated learning. Then we can introduce some incentive mechanism. As such, blockchain has this process, right? So we have gas value. So whenever miners are doing mining operation, we are giving some gas value. That is actually called incentive mechanism, right? So the incentive mechanism we can straightaway apply to federated learning, where we can make high performance or high quality data will be given more reward or more incentive. Thereby we can make very good robust model. Because you give very quality data, use very quality data training the machine learning model, I will give more reward. So we can make a very robust or very accurate model. That is the idea. So incentive mechanism in blockchain we can apply to federated learning to make very good model. That is the idea, right? Then we can make a verification mechanism of inherent blockchain to make high quality and trustful edge devices communication. That is another aspect of advantage of blockchain into federated learning, right? And you can apply these blockchain to protect from poison attack or improving performance production or fast convergence. That is another aspect. So these are the advantages why I should apply blockchain to the federated learning, right? Let's see the case study, right? So data-driven cognitive computing, blockchain-based mechanism, right? So you can see the first process is initialization. We initialize the machine learning model, and second process we do local updating of training model, and third one, the local updated model is given to blockchain for cross verifications, and after verifying by the miner, that will be added into block and block propagated to all our clients. That is the idea, right? So here inherently we have the blockchain to solve the issue of verifying the developed model before putting it into the blockchain. That is the idea. The security mechanism we are imposing in this, right? Right. So the issue is some malicious devices in the industry may be giving wrong data or falsified results. To solve that, we can compare between the data size and the computation time taken for the training. If it is proportional to each other, we can rely on it. Yes, this amount of data is used, probably this amount of time it will take per time, so he is taken that amount of time. So he is not malicious, right? Suppose the amount of data and the training time is somewhat deviated from some value, we can guess he is not attacker. He is giving false data only. That is the key idea we are applying and to solve the issues. And we make a Markov decision process model. That is one of the decision making model based on probability, and we can apply some game theory of two-player game, two learning mechanism to select the aggregator. Aggregator is the one, the server. So I told you that we are going to select the server of aggregator on hardware. So, but good aggregator has to be selected. For that, we use game theory approach and two learning algorithm to select best node as a server node to aggregate the model. So that is a mechanism, right? We'll go to second use case, the permissioned blockchain frame for secure federated learning. Right. So here one of these salient feature is homomorphic encryption. Homomorphic encryption. That is the key mechanism applied under this case study. Homomorphic encryption is one of the very excellent encryption scheme, where the scheme allows us to do computation on encrypted data. As such, you are doing a computation on plain text without decrypting. That is one of the excellent property of homomorphic encryption scheme. That means you can do any computation as you do in original data without decrypting it. You will get the same result. What you get the result from plain text, same result we will get it from encrypted data also. So that is one of the excellent property of homomorphic encryption scheme, which is used under this case study. So why this? Because I am going to send the encrypted machine learning model from local machine to server. The server can use the model without decrypting. If I allow to decrypt, I have to share the key. Somebody attack my model, they will do some function, right? So here I will send encrypted machine learning model without decrypting. My server can use that model to aggregate. So it is very secure one. So that is the approach they use under this case studies, right? So one of the excellent encryption scheme. You can set the data that by encrypting, anybody, end application user can use that, do computation without decrypting. That is excellent, right? Right. So under this case study, they used trust authority and user, nodes. They classify the computer into different types, nodes, and this is the mechanism of entire flow. For handling security purpose, they nominated some of the nodes as enclosure. Those enclosures are going to be verify the locally generated machine learning model whether it is secure enough or not, or it is malicious or not. So here n number of enclosure node EP nodes will be employed to check the validity of the locally generated machine learning model before getting into the blockchain. So those checking unit or nodes actually doing the checking in using these approaches. That is, first they will validate the signature of every node, and there is a conformity checking between homomorphic encrypted data and unencrypted data using homomorphic property, right? So that is another checking we can do that. And third one, they use the accuracy of the model what they communicated from the clients. They will take the model that is communicated to the client, they will apply some sample data, they will see what is the accuracy the model is producing. If the accuracy is somewhat good, that model is recognized as a good model, it is further ordered into blockchain. Otherwise, it is treated as a malicious data or malicious model. Some attacker introduced the model, we drop the model. So that is another checking we do that. If accuracy is lower than the present threshold, then transaction will be discarded. Here the sentence transaction is associated with blockchain. So any data communication is called as transaction, right? So you see that local nodes are training the model using local data, they are communicating to blockchain to art. Before that, the checking units, n number of checking units are applying these mechanisms to validate the models are valid or not, or attacker what. Then it is allowed to add it to blockchain. So that is the key of this. Right. We move to third case study. Privacy preserving attack robust federated learning. That is bench handling. You know that bench handling attacks are common for distributed computing. Right. So what we introduced in this model, they have done this bench handling resistance algorithm, which is actually they are accepting the distributed stochastic gradient descent results by selecting one of n model in each iteration. Every time I will get update of trained model from n nodes. I will select only one node from n, so that I can avoid lot of computation. From that I can avoid lot of computation. That is the idea. And I can select only best model at a time. So I can develop quickly, very quickly best model from that. That is another idea. So I will select only one model among n number of models coming from the client, and using the equivalent distance computation between the gradients. So which gradients are useful, I can evaluate by using a mechanism for equivalent distance computations. Then which is guaranteeing the convergence very quickly because I select best model at a time. Right? Then another approach is time mean. That means after getting all the gradients, it is sorted into ascending order or descending order and larger smaller part. Then only middle values are taken. The larger ones, small ones are eliminated because the intention here is, I guess the larger values are somebody attack values. They are just trying to disturb. And similarly, the small values are another attack value. They don't want my model to learn anything, so they are introducing small changes. So some intermediate values are good, that is my guess, and that will be make my model to converge quickly. So based on the base, we will accommodate only the intermediate values of models coming from the clients. We will omit the larger value and small value. So that is the key mechanism, right? Right? So this reduces the influence of the central server and malicious client. Why? Because I am selecting only one at a time, and also I am eliminating a larger one, smaller one, that probably they are attacker or malicious one. So that is this. And the mechanism uses Cosine similarity to compute the similarity between the coming models. So that Cosine similarity and full homomorphic encryption, that is already we discussed, that homomorphic encryption will allow us to use the model without decrypting, right, for safe applications, right. This is the system. Okay. See that? So here we use key generator to generate keys for encryption purpose. We share to client as well as verifier. We use an entity called verifier here that is verifying the model that is communicated from the clients, whether it is malicious or good user. Then blockchains are used to store the developed model and make the data transactions and the model sharing between the clients. And the solver is actually aggregator, which is going to take all the model developed by the clients, it will aggregate and it will put it into the blockchain. So this is a key mechanism, the flow is right. This is this algorithms, local computation. We have local computation, normalizing judgment, and model aggregation, 3 processes. So that local computation is all my clients are training the model, machine learning model using the available local data, and they normalize the model. That is very important property, and they communicate normalized model to the server. That is what called local computation. Where this is the algorithm for model update. You know that traditional approach. So new weight value is equal to old weight value plus learning rate and the gradient. This is the universal formula for machine learning update. So that is utilized here to make the training of machine learning model. Right. So here this key process is important one. That is all node will communicate normalized model. What do you mean by normalization? Under normalization, all data are converted into between zeros and ones. So using this property, I can detect attacker. So anybody in between attacker is changed the model, I will not get values from zeros to 1. It will be probably going to change. So that property I can use to detect the attackers. Somebody attacker, if they are introduced some malicious model or not, right? So that is the idea. So that is the key idea, right? So that is what called normalizing judgment. So I know that my models are normalized and communicated. So whenever I communicate, receive the models and I'll aggregate and I find out the length, if it is equal to 1, it is still normalized 1, then nobody attacked my model. If it is not equal to 1, somebody disturbed my model. Because I know that all my local clients are normalizing the model and communicating. Under the circumference, the summation or length of all my received model will be 1. Because all the models data values will be 0 to 1 under normalization. So if sum together all the model, it will be equal to 1, or the length of the model should be equal to 1. If it is so, I can guess no one disturbed my model communication from the client to server. If suppose not, somebody injected some malicious model, that's why I am not getting this equal to 1. So I can easily detect. That is the key idea, right? So this is the entire process, local training, normalization judgment, and how the solver is doing the operations, all those things, right? And another interesting phenomenon under this case study is cosine transformations. They are utilized for similarity measure. Cosine transform is involved some high computational complex process. The cosine value how to compute. So that we can avoid when you do normalized based data. So under normalized data, the cosine transform will be equal to dot product. So I can avoid the computation. So two advantages I am getting by means of normalizing my model. One is I can easily detect the attacker. Another one is the computation complexity of cosine transform. I can solve it very quickly. I just dot product instead of making cosine value computation. That is the idea, right? So cosine values can be avoided, dot product. And another excellent feature, after this dot product, the values of the dot product, they are applying to remove function. What is remove function? It is one of the famous function, application function in deep learning model. So remove function will return whatever value you pass as outcome if the values are positive. If they are negative, it will return 0. So applying this redo function on the outcome of my machine learning model, I am trying to find out any negative values are there in my communicated model or not. That is my intention. Why I should do that? Because negative value of these values or gradient actually opposite direction of what I am doing updating the model. That probably because of attacker. Attacker want me disturb. I am updating the model in a positive direction. They want to go for other direction, so such that my model will be failure. That is the intention of attacker. So I can detect the intention of the attackers by detecting sign of the gradient by using redo function. That is the idea. Another case study, COVID-19 diagnostic based federated learning. Right. So we already discussed that federated learning is applied to COVID-19 diagnosis. We can use this federated learning because I can get all over global data to train the model. My model will be more robust, more accurate to diagnose the COVID-19. That is the idea. Right. So they utilized the blockchain mechanism, proof of work mechanism, consensus mechanism, and distributed ledgers they utilized, and they have analyzed the blockchain forking as well as model performance stability. Right. So this is a key idea. All the hospital they train the model using their local data. They will communicate the model through wireless communication to blockchain. So all hospital trained model, machine learning model on the COVID-19 data set is available in the blockchain. Those models are taken from the blockchain and it is aggregated by a server to make a global model. So that global model is combination of all the model of this all the hospital all over the world. So those models will be more robust. The aggregated model will be more robust. We can very accurately detect the COVID-19 presence or not. So that is the key idea, right? So this is the use case, and next use case is blockchain empowered digital twin for federated learning. Right. This digital twin is a very fantastic concept introduced in Industry 4.0 and later Industry 4.50 also. Right. What is a digital twin? We make a twin of anything in digital. You can make twin of the chair, you can make twin of your shoes, you can make twin of a person in digital version of the entity. That is what digital twin. In Industry 4.0, people are interested to make digital version of their machineries, their process, everything what is happening in across the industry, to make a digital replica of the entity so that I can analyze what is happening in the entity without touching the physical entity in the digital version of it in my computer itself. I can sit anywhere in the globe, I can take my digital version of my factory of machineries, I can analyze what is happening in my machinery. And this digital version of machinery will give an insight what will happen after 1 year or after 1 hour or what after 1 week in the machinery. This is what we call it as predictive maintenance. We can detect the malfunctioning of the machineries prior before it happened using the digital version. I don't need to disturb my production because of faulty machinery. I can predict the fault in advance. I can do readily, right? So that is the idea, one of the use case of this digital. Like that, one of the another excellent use case of digital twin is for autonomous car. So people are developing autonomous car, driverless car, right? So those driverless car, we have to test. We cannot go and test the driverless car in actual field, right? I cannot make my connected car or driverless car to run 100 km per hour and test it whether it is functioning without hitting the person in the real traffic or not. It's very difficult, right? So I can simulate such traffic scenario in digital world. That is called digital twin of the traffic scenario. I can put my car, digital car, into the traffic scenario. I can analyze how my car will function or behave in a traffic scenario. This is one of the excellent use case of digital twin. Similarly, space applications. I cannot go and test something what is happening in the space by putting my rocket. So before that, I can make digital twin of the space scenario and my shuttles and whatever the things I want to analyze, I can do in a digital version of it. I can design my shuttle very properly, right? So very accurate manner. That is another use case. So that is the excellent use case of digital twin. So making such a digital twin, we require machine learning because we can develop digital twin by means of putting the data and making a machine learning model only. Digital twins are nothing but a machine learning model of the machines or whatever the entity. So here federated learning is coming into picture because we want to use all client data, all factory data to model a machinery. Suppose I want to develop a driverless car digital twin, I have to take all the model from all companies, Ford or Hyundai, whatever, because the digital twin should be applicable for all the factory machineries, not only one. So I need the data of all the clients. Similar, that's why we go for federated learning based digital twin mechanism. So we go for digital twin development using federated learning, and especially we use edge devices to develop such kind of digital twins in the real scenario. So there the security issues are coming, and for that we are using blockchain, right? So this is a use case is actually for edge devices. I can go here, right? So the idea here is mobile phones, laptops, whatever the mobile devices or smart gadgets can collect the data, and they can communicate to the access point, where access point is actually doing the local model training. Because these devices, if you ask to develop a machine learning model, they are resource constrained one. They are battery operated, they are low computational power, they cannot do that. So idea here is, we'll collect the data only from all the devices, and we'll do machine learning, local machine learning model under access point. No access points are there, we use that for internet connection. Those access points are somewhat computationally good comparing to a mobile phone. So those we can use for developing local model, machine learning model. So these devices are very good to give the data because they are scattered over all the places. So they can give data. So we'll collect the data and we'll do machine learning model development, local model in access point. These are local model because it is only exposed to local data. So these I can do with the n number of access point, and all these access point model I can combine in base station of mobile communication, because base stations are connected with a number of access point. So they can easily collect this local model and it can aggregate. So what they did in this, they utilized already available infrastructure of mobile communications to make local model and aggregate it. That is one of the feature, right? So, and base station I aggregate, right? This aggregated model also is local in some sense because they are got exposed of the data of their local devices or local access point. Like this base station, there are n number of base stations globally, right? So every base station is developing such a model like connected with the access point. All these base station models can be combined to make a very global, robust, accurate model. That is what we do. So here, two blockchains are maintained. One blockchain is to moving the data, sharing the data between the mobile devices and the access point, secured way. Another blockchain is to share the global model in between the base stations. They utilize another blockchain. So this is not an innovative idea. They utilize the already available infrastructure. How we can use this infrastructure for this federated machine learning digital twin making purpose. So that is what the idea they did. Right? Right. So use cases for blockchain for federated is over. We are moving now federated learning for blockchain. How federated learning mechanism will help for blockchain. Right? So that use cases. Right? Federated learning for cyber threat hunting in blockchain based IIoT networks. What is IIoT? Industrial Internet of Things. On industry, we are connecting all the things into internet. That technology is called as Industrial Internet of Things. Right? All connected. That is the mantra of Industry 4.0. Everything in the factory is connected to internet. You can get data. You can monitor them. You can control them. That is the idea. Right? So such industry IoT case, threats are there always. Right? Well, the machines are connecting to internet, sharing the data. People will attack and change the data such that the factory will do malfunction. Right? So such kind of threat detection we are doing, and usually all in this IoT and connected machineries in industry, they are sharing the data through blockchain because to make privacy and security. That is what the default scenario. But even that, there may be attack to make blockchain malfunction. So how that malfunctioning or attack in the blockchain can be solved using federated learning. That is the use case of this. Right? Okay, detecting anonymous in blockchain-based IIoTs in smart factory. The factory which is uses IIoT concept and machine learning is called smart factory. Is very crucial protecting the network, where federated learning can build for this threat reduction that is called block quantum, right? Because it is for blockchain we are doing. So this block hunter utilized cluster-based architecture for anomaly detection, and they applied autoencoder, random forest, k-means, principal common analysis as a key machine learning mechanism to detect the attacker in the blockchain. Right? Usually, if you want to detect, I already told you that blockchain is used for privacy security purpose. Usually, how the blockchain is protecting from the attacker means all factory or machinery data should be given to blockchain. All miner will mine the data, and in the consensus algorithm, if any attack data is there, they will not agree. Then it is treated as attacker. That is how it happened in blockchain. But you see, this is very complex process. Every machinery data, I have to ask n number of miner to process it and to verify it. It is time consuming and also resource consuming. These I can avoid simply doing some machine learning to locally detect the attacker, and I am not going to disturb my machine blockchain miner to do so many processes. I am avoiding the loading of my miner under this approach. That is the idea, right? So what we do, we use federated learning to see that how the model frequency done, and a global model for detecting anomaly. That is what we do here. Right? So fork on fake blocks. No blockchain fork. Whenever I do some protocol changes, some changes in the blockchain, that will not be, the changes will not be agreed by all the miners. So definitely, what will happen next? The forking will happen. What is forking? Breaking of blockchain into two blockchain. So this forking is allowed normally because some of the client may have updated their software. Because of that, blockchain length will be increased. Then all other miners will see that usually the blockchain length is this, but this is increasing. Okay, so probably is not into our blockchain. Like that, they omit. Then the forking will take place. Two blockchain will be generated. So that is what normally happen. So this is available in blockchain already. Then attacker will do this, increasing the blockchain size such that multiple forking will happen. The entire blockchain will be collapsed. That is the attacker intention, right? So that forking and all we can avoid by means of this machine learning, federated learning based detecting the attacker, right? So fake blocks, you know that some of the stolen malicious transactions, fake block that is eventually discarded and accepted based on mismatch measurement, right? So what we do here, we will develop a federated machine learning model to locally detect the fake block that is communicated to blockchain. Then we can avoid unnecessary computation of miners to verify it. Because under connected factory, smart factory, there are million and million devices are connected. For every million machines, every miner has to check whether it is very good block or good block like that. It is very highly computational complex. That we can avoid by putting federated learning locally to handle these issues of fake block detections, and we can avoid large computational complexity at the miners at the actual blockchain. That is the idea, right? Then federated intruder detection. That is again security purpose. Somebody attacking my blockchain, I have to detect using federated learning, right? But it is in the case of smart transportation system, connected cars. The use case is for smart transport system or connected cars. This connected car also called as Internet of Vehicles, Internet of Things, Internet of Vehicles, right? So this is smart transport or Internet of Vehicles, and because these vehicles are connected wirelessly, they are prone to attack. Attacker may easily attack. That is the idea. So to solve this, we need usually this data communication among the connected vehicles are done through blockchain for implementing secure transactions. There are some attacker may be attacking my blockchain. To avoid that, I can use federated learning, right? So this federated learning is called as context-aware transform network. They are going to analyze the spatial temporal vehicle traffic in a given place, how many vehicles are there, and how many data communication has to come. And based on monitoring those, I can detect the attacker. Right, that is the key idea. Right, so blockchain is managed to federated learning, provide edge node safe and distributed reliable transactions. That is the key idea, right? So avoid the faulty update. Miners verify distributed local updates from participating car using a threshold value. Suppose the accuracy coming from their values are not within the threshold, it will be treated as a attacker. So this is a scenario, you can see that. We have blockchain manager. The blockchain manager is actually involved in the generating the signatures and global update model, and all the vehicles, connected vehicles are doing this local training of available data, machine learning model, and they are communicated to blockchain. That is this. So last use case, resource management in blockchain enabled federated learning. Right? Resource, it is required for especially edge nodes or resource constrained nodes when you are involving for federated learning or blockchain operations. Suppose you are developing blockchain using mobile devices. Mobile devices are nodes. They are low power devices and they are battery operated. If you are using them as a part of blockchain nodes, then the resource management is very, very important, because they quickly drain out, battery drain out, right? They cannot able to handle the mining of large block size, because different mobile devices having different computer resources. So resource management is one of the crucial thing when you are going mobile device based blockchain. So for that, we can use federated machine learning to handle the resource management. Right? That is the key idea. So training latency may increase the federated learning because of mining procedure in the blockchain. So you have a mining process through blockchain, you do the training, and thus will increase the latency. That is the main concern. And the FL have energy and CPU constrained devices in the network lifetime. That should be done. So there must be a decision making unit to make optimal decision. How much amount of data a mobile device can handle for training? Because if it is handling large amount of data, the battery will drain out. They are not able to handle. So what is the amount of data any mobile device can handle, and what is the energy that any device can have and do that computation purpose, and what is the block generation rate that a mobile device can use? Because if you are making a large block generation rate in the mobile devices, their battery will quickly drain out, they will die. So to optimally manage their resources, I have to say, yeah, you are a mobile device, you are the part of my blockchain. Now you are generating some block, but you see that you will generate the blockchain at the rate of this, then only your battery will come at least 1 day or 2 days like this. So I can suggest some block generation rate by analyzing the data using federated learning. That is the idea, right? So I decide block generation to minimize system latency, energy consumption, and we do incentive cost without compromising the target accuracy. That is the idea. Resource management, right? So we use deep reinforcement learning based mechanism to make optimal decisions to reduce this complexity of mobile devices, right? So the result says that we can reduce the latency of 12% in block generation, as well as we can save a lot of energies of the devices because of approach of using deep learning mechanism to resource allocations, right? So this deep learning mechanism balance between energy consumption and system latency. It can help to deploy blockchain technology using mobile devices. That is the key idea. So when I try to make blockchain on mobile devices, resource management is more crucial part. For that we use reinforcement learning. Right? So this is a mechanism how the blockchain is working. Mobile servers are sending the data, and devices are doing data blockchain, and miners are doing mining, and then mined data winner is adding the blocks. This is a traditional cycle of blockchain, where this is our deep learning mechanism, which is actually making decision what is the block rate. So what is this action phase of this deep learning mechanism? So this deep learning mechanism actually decide what is the block generation rate, mu, and what is the data unit, how much each device can use for training, and what is the energy unit remaining with that. So those decisions we can make by using this reinforcement learning mechanism, and this uses a reward function. Reward function is the cost function for any deep reinforcement learning mechanism. Using that only decision making is made. So these typically any reinforcement machine learning or deep learning, there are two. The function is the cost function or reward function is function of two things: state and action. States are nothing but what we measure from the environment to make decision. That's called states. And action is nothing but what you do to solve the problem, that is action. So these two sets should be used under deep reinforcement learning. So that what function you are doing based on that optimization is done. Here we want to decide what is the amount of data device has to handle. For that, the data device data amount divided by maximum data. So this is the component. It will help tell the model what is the amount of data the device should use. And I am incorporating energy level of the device. So what is the energy level is available? It has to spend for training the model. So that energy level I am accommodating by this term, E by E max. Then what is the length of that data latency of the computation that I am including in this part. And there is the I is the probability value, probability of packet transmission that I am including. So putting together all in a mathematical form and running a machine learning model, I can make an intelligent decision. What is the amount of data any mobile device has to do for training, and what is the energy level they have to spend, and what is the block generation unit generation rate they have to use. So this optimal parameter setting I can do to all mobile devices so that they can involve in the blockchain networks without much degrading the performance, draining out their batteries. That is idea. Right. That's all I've done. Right. Any questions? 5 more minutes or 6 minutes extra.
Are there any questions for Professor Vijay?
Yes.
You presented very interesting and promising use cases.
Yes.
My question is, I understand these use cases as thought experiments. Is there any real-life experiment with this technology?
Real life experiment. Yes, of course. In medical science, people have done some experiment, and few of the use cases they have experimented and reported with the result only. I am not getting to that because my intention is to give what technology, how they can do what wonder. That is what my intention. I am not included the experimental study results here because of lack of time. They have done some experiment. It is not only concept wise. Some experiment has done and it is proved possible. Yes.
Thank you.
Yeah, me in my university also, we have done one experiment for medical science where we are trying to make federated learning for physiotherapy exercise. We are developing an augmented reality based physiotherapy exercise unit where the patient can engage themselves by an augmented device. We will be giving some very good instruction how to do the physical exercise without any physiotherapist in presence. So for that, we'll collect the data from various hospitals using federated learning, and we use blockchain to securely share the data to all our clients. So some of the experimental work has been done, and it is not in large scale deployed. We are working on it.
Yes, another question. The machine learning usually, supervised machine learning usually relies on the labeling data.
Yes.
How this problem is solved with the real data coming from devices to be labeled?
Yes, we have to develop label. We have to develop the labels. For that, we have to do some experiment called data collections, where we have to go to the field, we have to collect the data and label it and use it. And we verify it before deploying, cross-checking. That is what we will do. And few of the works we can do without labeling unsupervised learning also. There are very good unsupervised learning mechanism. For example, in one of the case studies I said that k-means clustering mechanism, where you don't need any labeling of data. I can cluster the data into two groups without labeling also. I can collect the data. I can do similarity measure. I can divide it into two groups. Good data, attacker data like this. That is possible without supervising also. There are two approaches, supervised learning and unsupervised learning. We have some of the algorithm unsupervised learning also, like k-means clustering and hierarchical clustering, and like that reinforcement. Of course, this reinforcement mechanism also not labeled one. You don't need any labeled data. It will learn from the environment. So it is keep on interacting, learn. It is the approach. It's not a new approach. Deep learning, reinforcement learning is not new approach. It is what we do for learning anything. For example, if you are trying to learn bicycle in your school days or your childhood, what do? You are actually applying the reinforcement learning. What is reinforcement learning? I will learn by doing mistake. I'll reinforce my actions to correct it. So while I am doing we are trying to learn bicycle riding, what do? You apply some approach, you will fall down. And you'll see, oh, I did mistake. So I should not be done like this. So I have to do like this. Now without falling down, I want to ride. Then you apply that strategy. Again you will do some mistake. You will learn from that. Again you will adjust. You reinforce your action such that the error in the process will be minimized. At one point of time, you reach the correct strategy, you will be able to ride the cycle. Same mechanism is implemented in a software which is called as deep reinforcement learning. So you see, these technologies are not new. It is from our human system only. Everything is taken from the biologists. Nothing we are creating. It's all God created. We are just mimicking into the electronic system and software. That's it. So you want to do some wonder research. You can just watch the nature. It has a lot of innovative things. You can do domain transfer. That is excellent. What they did here, what is neural network machine learning? We have taken the mechanism of our brain system, how it's function, that we have transported into another domain called computer program. Right? Same thing. This deep reinforcement learning is nothing but what we do when we are learning new things, the strategy or the mechanism, what we apply for learning any new skill. Same mechanism is implemented in the form of a software which is called as deep reinforcement learning. So my advice to make innovative research, keenly watch the nature. It has a lot of steps just to do the domain transfer from physical world to electronics world or digital world. That's it.
Hello everyone. I'm going to talk about detection anomaly in network traffic, and with special point to research and implementation. For any decision-making process, it's important to rely on accurate data, but for operating and managing IT infrastructure, we collect these accurate data from the monitoring. We need to monitor the system, to manage it, and to operate it. Traditionally, for years, we've been using SNMP protocol to collect the data from the networking and IT devices, and to inspect these data. All we know how it works, very descriptive. We can detect and discover the bandwidth, CPU usage, memory usage. But that's all what we have at the top. Inside, our network is still a black box. We need to answer the question who and how is using the network, the IT system, why the network or application operates slowly, what kind of traffic or activity is happening in our network, and for this special topics in cybersecurity, is there any security problem with our network? We, with these elements of SMP, cannot answer to these questions. So, the big step forward in this direction is introducing the NetFlow protocol, which collects the data from the routers, who keeps the track of each communication in the network and account how many bytes and packets are transferred in the network, and export this data to central server. So it's a bunch of communication logs. What we can produce, what we can analyze, and make some statistic and get insights into data traffic structure. With these instruments, we can have a very descriptive statistical view about the structure of the network, go deeper from the routers to the interface level, the host level, to see who is doing what in our IT system. The software is called NetFlow Analyzer. It's commonly based solution to this problem, and for the at least last decade, there are the products working and producing such a nice statistical of view of the network. And to give you some example, this is something that happened several years ago in the academic network of Serbia. Here we have some unusual behavior in the network traffic. We call it anomaly. So going deeper into interface level, we can inspect this anomaly and finally allocate who is the victim and who is doing that. In this case, it was one compromised computer on our network who had a malicious software participating in some DDoS attacks on botnet network. And another example, we were under attack. I believe that in this case it was the website of the Ministry of Education who were under attack, and at the top level in the whole academic network we couldn't see any additional anomaly in the bandwidth, since there are a lot of gigabits per second, but in the data structure we see that all the other services were suppressed, having only one active. But if you go deeper into the victim side, we see a huge anomaly from almost small usage to enormous gigabits per second usage. So this is the example of anomaly that is happening, but relying on natural analyzer software, we can inspect visually. We can have alarming based on threshold. It's good that the threshold is not fixed, but dynamic according to the bandwidth to recognize the usage during the day or during the night. But still, this software, this approach relies on the volumetrics feature. How many bytes are transferred or packets, which is not enough. We have increased concern with the cybersecurity since the security threats continue to evolve in terms of scale and sophistication, while the business requirements needs fast reaction to security problems. The IT system today is very, very complex and still creates many blind spots. So we need a solution where the firewall is not enough. And ideally, we need to have full protection, full first monitoring, the whole system, to have discovery, to know the system well, to have asset management, to have full visibility, to have feature to allow drill-down analytics to investigate the problem. And one part of this complex full solution is anomaly detection to provide automatic reaction to prevent the system. This is the topic I'm going to talk now. Network traffic anomaly detection. The goal is to automatically detect irregular behavior. We call it anomalies. To do so, we need first to profile the traffic and to know what is the regular behavior. And this problem belongs to research area of network behavior analysis. And it's from some reports, security experts realize and want to see the value in behavior analytics tools and want to have automation to protect the break system automatically in case of some irregular activity on the system. Need to clarify that the anomaly, especially in the network structure, is just an indication of security threat. We need to analyze the threat and to allow deep investigation, drill down analysis to see the root cause of the threat and to detect who is the victim, who is doing that security problem. And we performed the research and implementation, which is supported by the project from the Eureka program. The name of the project was the Network Traffic Anomaly Detection System based on network data analysis. Short name is TRADE, and this is why this logo of the project is shown at the top right corner. The idea and the goal of the Eureka program is to get the research focused to the close-to-market product. So we made a research for the product to improve the product, which is NetVisura NetFlow Analyzer product, to get to provide a market-ready on the as a product that should be competitive on the market. So the research is a wonderful job, especially if you're paid for that through the project, and unless you need to implement your research results, and these results should work in real time to be competitive on the market. In that case, it's very stressful, very reliable, and we needed to set up initial requirement that could lead us to realistic and feasible implementation. First, we should rely on easily collected data in real time. These data are not labeled. There are a bunch of data coming and collecting a high data rates, so that in terms of tens of thousands of data items per second. We need to process them in real time. So obviously, NetFlow is a good source for this data, and the implementation requirements were to integrate into existing NetVisura solution, to provide persistence of raw data, a bunch of data for the deep drill down analysis, root cause analysis, data inspection and forensics, and also to make everything that the market-ready product needs to have to be flexible, scalable, configurable, user-friendly. So very, very challenging process. Let's focus first on the research part, what was done by the University of, my teams from the University of Belgrade and from the Faculty of Electrical Engineering. So, network data that comes to our server consists of source IP addresses, destination IP addresses, source port, destination port, and protocol, which identifies the communication peers. And combined with that, there are volumetric attributes, bytes and packets transferred between these two peers. That's all what we have. And this is unidirectional. So first we need to process this data, and the first step is to combine two unidirectional flows into one bidirectional flow, where we have source and destination, but in both sides, better name is initiator and responding part of this communication. So this is what we first do, and for the later presentation we'll use labeling for the source, capital and small s, and D for the destination part. Having this data, what we can do, we can aggregate the data by the some identification attribute. For instance, by the source IP address. We can collect and aggregate all the source appearance of each source address and summarize bytes, packets, and flows in a short period of time, what you call epoch, and the result is distributions of the data, of the how many bytes for each source instruction in this one epoch for several attributes, keys, and other attributes. We, as a result, can get several distributions of data in each epoch, for instance, in each 1 minute or 30 seconds. Network analyzer software do the same thing, but presenting only the top talkers, the first 10 contributors, as the most active elements and parts in the network. This is not enough. We need deeper to extract deeper information from these data. For instance, volumetric bytes in packets is not enough. There are many other security threats which can stay under the radar since they do not transfer many bytes. For instance, password brute force password attack or port scanning. We need a new instruments. To do so, we introduce and generalize the concept of the second degree aggregation. How? When we aggregate for the first element, we, on the second level, aggregate any other appearance of other attributes, and they distinct appearance and count them. For instance, if we have a DDoS attack, we aggregate by each destination IP address, but in case of DDoS, we count how many different source IP addresses communicating with this address, and we call these additional feature behavior features, since it presents the behavior of each individual feature. We can aggregate by any of these identification of features, source, destination, IP address, and port, and counting any other appearance of other identification of features. Another example is the port scan, where we can aggregate by the destination IP address again, or source IP address, and count distinct destination port numbers, and we'll see that in some case there is unusual communication with a large number, very high number of destination port used in between some peers. That's the benefit of using behavior features. But we have a lot of data, we have a lot of distribution in each epoch. We need a mechanism to compress, to transfer in the simple form, and this is one approach. Could be and is machine learning. We cannot rely on the labeled data. Maybe unsupervised machine learning could solve the clustering problem, but there are a lot of data. Unsupervised machine is very complex and computer consuming. Much more feasible approach is to use the entropy. What is the entropy? Entropy is the measure of evenness of the data distribution, and the benefit is that we, using this simple math, we can transform the distribution of data into a single value. A single value could be a number which presents the measure of evenness or randomness of this data distribution. Why it is useful? If we have more even data in the distribution, the entropy will be near 1 in this case, or if we have some unusual peaks and spikes in the data distribution, it's less even, the entropy goes down. The entropy is lower. So data distribution per epoch, if you have if we follow during the time, we'll have the time series data the entropy value, which represents the behavior of this specific feature. So, if the data is more or less even, we have the small variation near to 1, but in case of some unusual spike, unusual behavior, we have the entropy drop, which could be in time even visually observed, but we need a mechanism to automatically detect these changes. So, the goal is to detect changes, and how we can do that. So, it's easy, obviously, and visually to see the changes. In this case, the variation is small, but sometimes variation could be higher, and it's not that easy. So the changes depends on the variation. We need to measure the variation as well. So the first step is to have some normal or average value, what we call the baselining, in using exponential moving averages to see the blue line here, the average, but which change and follow the changes on the real data. Very useful for the data during the day and the night. During the night, usually the data is low. The next step is to calculate the standard deviation, the variation from the baseline, and to baseline this variation as well, since the variation could also change in time, to have the average variation. And now with we can set the range around the baseline, multiplying the variation by the factor experimentally is used, and set the best performance is 4 times more variation to have some dynamic thresholds. And indeed, with this threshold, we see that this anomaly, these changes could be detected, and we can produce an alarm if the threshold is crossed. Usually it goes down, but sometimes the entropy can increase. But it's nice and very descriptive in theory, but in reality there are many other challenges. First, the previous charts were faked with artificial data, but now I'm presenting the charts from the real data set. So we have small variation and pretty narrow threshold until we have a huge anomaly caused by port scan attack. In that case, if you have an anomaly, this is also data, and the system performs the baseline, the averaging, the baseline, adapt to these changes. And during the time, very soon, irregular data could become regular, and even worse, standard deviation will go higher and higher. The threshold is going very wide, so we can not detect anymore the data. So what we need to do to correct the baseline calculation by freezing or stopping calculating the baseline and standard deviation during the attack. If we recognize the anomaly, we should keep the previous value. Very obvious, and in this case, useful in detecting these anomalies. But we have another problem: how to initially set up the system. We need to set up some standard deviation. If you take too high value, when we start calculating the system, what would happen? That deviation is too high, and it takes time to stabilize, But in case of the anomaly, what we can see here, the standardization couldn't get enough time to get stabilized, and the anomaly is not detected since the anomaly is still inside the threshold margin. Even worse problem if the standard deviation is too small and the next epoch, the regular traffic will be out of the threshold and the baseline standard deviation will be frozen and all the regular traffic couldn't be detected while the irregular anomalous traffic could jump into this threshold and we get the completely opposite results. Regular traffic is recognized as anomaly and irregular as normal. We need a way, why someone can say, okay, that's the only initial. In reality, we still need to talk about implementation. It happens that the software is restarted and each time the system needs to have flexible option to adapt to the changes to work properly as expected. Then volumetric features are good for the basic and mostly manual inspection, but for the entropy it's not very useful since they have a huge variation, pretty wide this threshold, and the threshold could easily drop to 0, which is useless for the detection since the entropy is positive value. This is why we rely our calculation and our solution to behavior features, since we can explore and investigate behavior features, not rely only on the volumetric features, bytes and packets per second. And the experiments demonstrated that these features better capture the communication patterns. So our goal is to recognize the communication patterns in a bunch of data, what is happening, as we can see here. It's very useful to have behavior features. Another problem is if the threshold margin is too narrow, so the system detects some anomalies, but is there a real anomaly? We cannot see since it's very small and narrow. Another problem is how to compare anomalies with different amplitude. So the approach is to normalize the entropy based on the margin of thresholds, to extend the margin, no matter how wide or narrow it is, to the range of from 0 to 1. And now from 0 to 1, we can inspect that we really have the cross of the threshold here, and we can compare different type of anomalies, different intensity of entropy detecting these anomalies. Very useful, not perfect in all cases, but very useful. The common problem with entropy-based anomaly detection is a lot of false positive alarms. We need to adjust the margin, and some smaller anomalies, not anomalies, some smaller changes could cross the threshold and produce alarms. We need a way to eliminate these false positive alarms, and we introduce anomaly score. What kind of anomalies? Short in time, just one epoch, for instance, and minor anomaly, not just barely crossing the threshold. We need to have into calculation these two measures, and we do that by calculating the distance in each epoch and cumulating this distance during the time in the last, let's say, n epoch, and we get the anomaly score, cumulated anomaly score, and we can set an another threshold and eliminate small false positive and just extract a real anomaly which is obvious, visually obvious for our humans here, and see the graph, and you have only one real alarm. Okay, in reality, we have a bunch of data, we have a high bandwidth, and it could be even high anomaly, but could be covered by a lot of regular traffic. So the anomaly could be masked by regular traffic, and the experience shows that it's useful to partition the whole data into a smaller subgroup to extract different type of traffic where the anomaly appears could be notified. So we propose to extract by protocol, TCP traffic, UDP traffic, or ICMP traffic, or by services to extract or to focus only to DNS, web, or email traffic, or to exclude some well-known active server what we believe that works properly, like DNS server or website or proxy server, and analyze other activities in the network. And much better view, for instance, we have small anomaly here. When we only focus on TCP, we see that there is significant changes in entropy with this in TCP traffic only, which is not the case if we observe the, for instance, UDP traffic. Okay, next, we need to somehow profile the communication in the network. And the next step in our research was to recognize the communication, and we said, okay, in our communication it could be only one appearance of one feature, one element, or many appearances. One destination, many sources. So what we have done is to having a label 1 for one appearance and n for many appearances for source IP address, source port, destination IP, destination IP. The permutation of these elements leads us to 16 communication patterns. In our case, port scan performs from one source, it could be one or many source IP ports, to one destination address, to many destination ports. That's the port scan. We can DDoS, we have amplification attack, or diagonal scans, TCP SYN flooding attack. We can recognize by this communication behavior. We developed this model, which is very useful in analyzing which features, behavior features, are triggered by which kind of communication patterns. To do so, we modeled different kind of anomalies in each of these communication patterns. Put these synthetically generated anomalies in regular traffic, gradually increased, and we performed analysis, entropy-based analysis, and what we got is how the features are triggered by which anomaly model, which communication pattern. And we can see quite a regular periodic behavior of the communication model which triggers each feature. Why is it important? Because inspecting different feature, we can conclude what is the anomaly model, what is the communication pattern, and not only detect the anomaly, but also classify the anomaly. And based on that, we developed classification rules we have a lot of features, and another challenge was to perform multivariate analysis for different features to combine and extract the single alarm and single information about the whole activity, what is happening. That was the research part, and now we need to implement that with a test on real data. First, for this process could be presented as a high-level architecture with the building blocks for flow preparation, flow partitioning, aggregation, entropy calculation, change detection in entropy values, multivariate analysis, and at the end, we provide the user interface to alarm users, to notify users, which need to provide all the information, what the user expects, what the user needs. NetVisura software already provides monitoring tools, and Network Analyzer is one module of this software. We extend this function by providing anomaly detection new module in NetVisura framework. And the usual workflow is that we have a single consolidated alarm, then providing the information about the problem detected. Then the user can go to another view to inspect these features. The entropy should need the meaning of the entropy, but also we see here the entropy goes down a bit because of activity. This is data distribution. Who caused these entropy changes? It was some particular IP address. Then next click on this IP address, this element, lead us to raw data filtered by this address and inspect each log communication, who's communicating with whom, where we can not only inspect the data, we also have visualization in time of these data for the selected time window, selected period, that we can further analyze by aggregating this data and inspecting other attributes in the raw data, which is a great benefit for the user, providing an instrument to drill down analysis with thousands and millions of data in real time. Okay, to conclude, let me summarize our novel research contribution. We generalized the concept of behavior feature. We improved by some particular solutions the entropy change detection process. Very important, we built communication patterns, 16 models for the communication patterns. It provided taxonomy to that, from which we created the rules for the anomaly classification for the implementation. And the implementation process is a hard work engineering task, but straightforward. The research was very, as you know, tricky. When you start research, you know in which direction you will end and where you will end. Fortunately, went to good researching results, which allows us to provide anomaly detection module in technological readiness level 7, meaning that it is demonstrated in operational environment. Still need to perform further optimization, performance optimization, and also work on the user interface and user experience. But it's not the end of the research and development. What could be done next is to work on security protection. Once when we confidentially and reliably detect security problem, the greater value will be to automatically reinforce security policy to the device and to automatically protect in real time, near real time, protect the infrastructure. To do so, we see a great value of using machine learning for the multivariate analysis and alarm consolidation, and also need to have security policy enforcement directly to network devices, to firewall, to routers, to start detect in real time. Thank you for your attention. Please, if you have some questions.
Are there any questions for Mr. Klein?
Yes, I would like to ask you, first of all, thank you for your nice presentation. When you have traffic bursts, and you told that in those cases the abnormality of the network traffic can be hidden, so sometimes, and how we can measure this abnormality, because there is no strict definition of the abnormality of the network traffic.
Yes, that's the common problem. What is normal and what is abnormal? It depends on the statistical results. So, to detect abnormal, irregular data, we need to have a smaller set of normals. Otherwise, irregular behavior easily could be hidden behind the normal data. So this is why we proposed partitioning into smaller. If we have a bunch of data, traffic consumption, we can extract by some logical groups this traffic, and anomaly usually occurs in one of these groups. So the normal traffic is lower in that group, and the anomaly could be detected easier. So we rely on the anomaly in data structure, not in the deep packet inspection, the packet payload. We don't know, we just observe the traffic structure. So we need to detect the anomaly and to have significant increase in some of these features, some of these data.
It might depend on the application. For instance, for some applications the traffic would be more normal, and for some applications not so normal.
Yes, exactly. And in our use case, in our operational network, DNS email service works regularly and very intensively. So it hides irregular behavior in these communication models. So what we suggest is to exclude these well-known our own servers, what we know they are protected by different means, and analyze the rest of the traffic. So that means that approach, the normal traffic is smaller, and anomaly could be detected easily.
Thank you.
Thank you. Yes, please.
Yes, also thank you for your presentation. It was very interesting. You were talking about averaging the traffic at a certain time frame. I was just wondering, what is the epoch that you're measuring? Is it based on a week, a month, or
No.
a day, shorter?
We use 1 minute.
1 minute.
One
Too much
minute.
data to get the average?
Yes, one minute. It's in real life, in real time, it could be even shorter. And we have a lot of data during 1 minute. We deal with thousands of data, tens and hundreds of thousands of data. We need a very a very challenging process is to aggregate all this data, provide second-degree aggregation. Servers and machines are very powerful today, and interestingly, CPU is not the bottleneck, it's not the problem. The memory is even higher problem, and now we are dealing and working on the memory optimization, and we also have some results from that. So to optimize the memory consumption, to have all the data during an epoch, we need to collect and combine and process all this data. It is memory consuming.
And you mentioned that you have trustworthy IP servers, whatever. Have you set up the signal, the alarms when the untrustworthy new IPs are coming with the bursty traffic, or this is?
We have a lot of new IP addresses, so
all the time.
just monitor and detect significant increase in some behavior, wherever it is. And in one of these slides, real cases, what we had a compromised computer in our network, so our own IP address produced a lot of irregular traffic. So
the reason why I'm asking is one of the commercial software that is used. They're doing the combination of untrustworthy providers from the IP addresses, and then they're setting up the alarms for the spikes. It works, it doesn't work, it also has its problems, so we're just wondering if you implement this sort of thing.
And now, well, it's a very good point and good approach. Some big big vendors could do that, such as Cisco or other big vendors. So they collect around the world all the data about compromised and malicious IP addresses, and could implement in almost near real time this kind of knowledge and information. Yes, please.
I want to ask you if adversary knows how the system works. Can he evade detection? What do you think? For example, now we know that epoch is 1 minute. Maybe I can access system 1 minute from one IP address and then change IP address or something like that. What do you think? Is it possible?
Yes, of course, it's possible. Every system could be faked, or you can avoid the system. The point is that there is no single key for everything, single solution for everything. Anomaly detection is just one part of the whole security protection, and there is also how attacker can avoid and mask the entropy changes. For instance, if they're active in one feature which increase the entropy, they can perform other activity, decrease the entropy, they can perform other activity to increase the entropy as well. So this is one problem. We also provide a solution to that problem, and this work is already published in scientific paper, and that's part of the research. Is not well covered by the literature in the entropy detection, but it could be interesting area for further research.
My name is Juliana Milczewski, and I expose you our work on security of financial software to support cryptocurrency trading. My co-authors are Nikola Popovic, also permanent court expert, and Branko Stanojevic, attorney and law. Let us what software support. Cryptocurrency trading is become a feature of advanced digital commerce in present time. Successful cryptocurrency trading is unsustainable without secure financial software. Our paper analyzed the relations between two close areas and individual deviation in the functioning of financial software. What's the basic functions of financial software? Financial software manages and records the day-to-day financial transactions of company, fixing aside expense and revenue management, accounts receivable, accounts payable, accounting, and reporting and analytics. A complete financial software system keeps track of an organization's assets, liabilities, revenues, and expenses. We are made analysis of possible omissions. Software-based tools for financial transactions have been used for many years in domestic financial operations. During that time, the following failures in financial software applications stood out as typical. We are analysis on the typical omissions. Namely, if the text data is entered in Cyrillic, the program accepts the input, this data, but does not see the Cyrillic text when searching. An example, it accepted Mirchevsky and Yevremovich in editing, but in searching, doesn't it visible. Further, software application has not implemented priority levels of operations. So, it is possible that anyone can read everything and even change the content. This is a remark of revisor officers. Each bank officer can read each accounting data for all users. Duration of operations is limited, but not aligned with the limitations of another software service that follows or precedes the downloaded operation. This is general synchronization problem. The next operation can wait finished previous operation and not flag for that. The other problem is in direction. The duration of the operation is unlimited, so financial transactions made on one day do not reach to recipient account until the next day or the after weekends and holidays. The duration of operation not limited in time. There is not flag for limited operation. Other problem is servers do not work continuously, but only during working times. Clients can't payment in all day, only in work time, from 8 to 8 p.m. or so. Currency exchange is not regulated in the same software service, so it must be manually entered or excited in another software service. This problem is very interested in two different change. Maybe a value in dollars not equal value in euros when you calculate it in the different applications. Server crash results in an activity of website of a bank or another company that performs transfer through a web application, which causes delays in payments, breaking long repayment deadlines, incorrect interest calculation, and so on. Many bank servers doesn't run in many days and doesn't not to bank website. How to solving problems? The problems caused by these omissions are mostly solved individually, and often through court cases. There is no professional agency, association, group of competent individuals who would make a general solution in disputed cases. Analysis showed that similar problems of insufficient security of software application are solved in the world. In text of paper, there are many examples of that. One is this. A team of researchers at Columbia University found bugs in 306 Android applications. Some of these Android applications have up to 100 million downloads on Google Play Store. The investigation was by Creelodger between September and October of 2019. See. The criteria that must be met in order for electronic transaction to be secure are the following: ensuring the privacy of communication channel, protection of secrecy and confidentiality of data, protection of sensitive and personal information from international and non-international disclosure, ensuring data security, detection of unauthorized modification of data in transmission, in order to software application must provide rejection of a transaction consists of procedure to eliminate possibility that the initiator of transaction then is sending the message. Authentication means a programmatic procedure for verifying the identifier of a user. That means person, application, or device that requires access to system or a network. Authorization includes the process of checking whether a person or entity is legally authorized for the rights it requests. We now are creating one concrete example. The user is regularly registered with personal documents in order to participate in cryptocurrency trading. He is personally identified. His data there are in the records of the digital currency trading company. The name of trading company is not allowed to say. Also, the user voluntarily accepted the merchant business rules for buying and selling the virtual currencies published on the digital platform, the merchant website. The contractual relationship is always established at the user initiative by creating an order for the buying or sale of cryptocurrencies. Now, this is diagram, digital money trading. First is the user identification, user account, user registration on the merchant's website. Merchant website send message to his own financial operators. If transaction sailing, this is flow. Financial operator is start sailing. Financial operator send transaction hash to digital wallet and other information to user. When started buying, user send message to merchant's website. Merchant website send message to financial operator. Financial operator send transaction hash to digital wallet. Problem is here. Financial operator send message that the action is finished, but this message not contains information about data. This action is not finished, so the merchant, the trader is the user's account was in debt, but money not received by financial operators and merchant website. If the order is created in accordance with the instructions given on the website, it is considered that the offer has been accepted by the trader's company. After that, the software application informs the user that the order has been successfully sent. The offer has been accepted. This is here. But the user card was debited with this amount, but the money was not transferred to the merchant's account, but remained in the user's bank account. This is here. Epilogue. This case is a consequence of incorrect functioning of the financial software or organization in the trade chain. The financial service company has an explanation. It's an electronic error. Financial service is not in possibility to solve this problem. This problem gives epilogue on the court proceedings. Concluding consideration. Our investigation is domain of software application security points to more action needs. Using more modern software tools in creative applications. Necessary improvement of legal regulations and rules of financial operation of trading and banking organization. Establishing of national agency for the data certification of financial software application that should be accepted for the regular exploitation. We insist out that as in pharmaceutical industry, as a building, as a technical registration of car and so on. It is known to our software engineering organization that export your software products. Swiss Lottery was client on the high technology games our company, and certification of software package was tested about 3 months in order to give certificate. In Serbia, environment doesn't sound like. Our company work with not modern software tools in creating applications. And it is not possible to reach all criterions for security software. Legal regulations also not has treatment in all areas that are in software applications.
All right, my name is Raphael Lani, originally Nigerian, but living in Czech Republic. And I'm in the second year of my PhD studies. And then I'm working on artificial intelligence and customer relation management. So I'm trying to see what is the impact of AI in terms of customer satisfaction. So that's what my thesis is all about. But today I'm presenting a paper, one of the top papers I did. I found this topic interesting, which I'm still working on. Anyways, I'm just trying to see what the impact of, in terms of macroeconomics and microeconomics, what is the impact of AI, all right, on social media influencing the perfect competition among companies. All right, so I'll put this paper in about a few slides real quick, and then it's we're going to go through them one after the other. So what are we talking about here, or what's my paper all about? So in recent years, we realized that AI itself is actually advancing, right? One of the biggest things or questions I always answer, right, it's usually people tend to think AI, machine learning are like the same. I have to always explain that no, machine learning is not AI, right? So I believe we all know that as well. So currently, social media is a big platform. I mean, in terms of marketing research, in terms of even sometimes data-driven, right? It has become so important even for companies, right? To influence the perfect competition among them, right? Company A, company B, and so on. Even with the research I'm making on AI and CRM, I often realize that this has become a trend between most of these companies, right? Also advanced level. So with the mass growth of, as we see, AI, so many firms have adopted it, this technology, to accelerate the growth of the business, right? And boost, of course, customer satisfaction, which is the end goal. In terms of my thesis itself, talking about AI, it's all about are companies ready to inculcate AI? Many organizations, many companies think we just go AI and then our process will be optimized, our process will be, but in terms of customer satisfaction, it's declining, right? It's the other way. So is this real, right? Are they ready, right? So I'm trying to create a balance or a kind of checklist where the companies, or a kind of model where the companies can go and say, okay, these, okay, we're ready to inculcate AI, right? That's what I'm going. So let's move forward. So what's the background like? What's it like? Why am I interested in this? In most basic form, right? AI is a field that integrates computer science and massive data to solve issues, the engineering behind the issues, right? So it encompasses the subfield of machine learning and deep learning together, right? So in a perfect market, how does it look like? How is AI influencing the perfect market? So we can see that producers, consumers have perfect knowledge about it. What is the industry doing in terms of changes in the aspect of products, all and anymore. You know, these are kind of research going on in the background, and AI gives a very good, of course, gives a very good advantage these days. Coming 10 years, coming 20 years, we know we cannot, of course, jeopardize the effect of AI, right? And its advantage in terms of customer satisfaction, in terms of the competitions in the market. AI is very important. Of course, it's the future. We can look at TikTok, Instagram. I'm very active on Instagram, right? Facebook, and you know, many companies are also using these platforms, especially YouTube, where you can also make money. And you know, some companies are utilizing these resources, right, to promote their product, and of course the company itself. So the algorithms, all right. So we have algorithms to gather intelligence about the audience, social medias, and then you can get data, right? Which helps them in customizing it. Okay, this data goes to this platform, this data goes to this platform, right? And how they can optimize it. So what's the method? So current research shows currently to provide an understanding of current state of research. Which AI has been integrated into social media. So, of course, the most important or the most effective channel right now, like I mentioned earlier, are these few ones. But additionally, some content platforms such as YouTube, Snapchat, they require where you reside, the demographics, basically, right? But consequently, AI can be used to analyze the data, analyze the content being shared, and the engagement. Then this data will provide, a valuable insight to the content types in order to help with the strategies and implementation. Thank you. So data analysis. I put up this data analysis is derived from market research to the publications and trends going in social media. AI in social media is used by firms to understand the market trends. Yes, we understand that, right? To gain upper edge among others, right? So if definitely it is believed that every company or every organizations that really want to be very competitive with others, they need to incorporate AI, right? Of course, we know. But in terms of customer satisfaction, what is the impact? Or how is it helping them to be more superior to others as well? So how AI through social media technology will influence a perfect competition, right? Close the gap of adding innovations, of course, and help companies to establish a brand through marketing. So as we can see here, we can see the average cost, the marginal cost, we can see the revenue itself, we can see how it's going. In the chart, you see is the revenue versus the sales output. We see the average cost, marginal cost, and we see the quantity in the perfect market, how it looks, right? And we can see, I picked, from this chart, we can see the regions from North America, and currently 2023 beyond. So what's interesting here is you can see how the chart is going every year. So if we can imagine, or in terms of data itself, right, the markets, how it's going to be in 10 years from now. Is it going to decline? Is it? But of course, as we can, if from 2016 that I picked and then till now, it's that we can see the difference, how high it's going. So it's very important, right? And the impact of AI. So what does the result look like? You can see 28.3 the global AI in terms of, this is as of 2018, right? How it is in a perfect competition companies to the growth of the impact of AI. So, just because of time. So critics, an imperfect competition. I don't need to talk, but we can see how it's declining. we can see how it's going as well, rather. Furthermore, right, the knowledge about AI it's very important, and we can see this advantage here in terms of innovation, making it unrealistic to have a kind of homogeneous product market as well. So in conclusion, AI technology and social media is used by companies to understand market trends and gain a very competitive edge by improving, of course, the market presence, effectively analyzing its competitors in terms of research, and of course, in terms of customer behavior in the market, which is very important for me, which is something I really also like to look into. How does the customer perceive it, and how do we perceive the customer as well, in terms of behavior, its usage, and so on. Again, it has changed the customer behavior in which the companies conduct their businesses to meet changing consumer behavior and satisfy your needs by analyzing monitoring, utilizing the data. And profit competition has allowed companies to make profits, of course, to stay in business and no more. In my universities, I kind of take some courses in entrepreneurial business, and it's very important how I'm asking questions about what's the goal of you setting up a company. You know, everybody talks about profit, right? Maybe right, maybe wrong, but it depends on what you name profit. But we have this data analysis program we run. I'm asking them to create some little chart how they're going to run the business, the cost, and these inflows. And it's so interesting that most of them come to the result in their first year of setting up a little company. They are making profit worth 5,000, 6,000. I'm like, oh, that's interesting. I want to do this kind of business as well. You know, manipulating data, right? So, of course, it's very important to consider it in terms of population, about the producers. So we can really see that AI itself, in terms of competitions among companies, it's very important. And of course, it helps, like I said, most important, my first point, which is about the behaviors, analyzing the presence, and of course, most important. Thank you very much. I will end it here. Sorry, I don't have the thank you slide. Thank you. So, any questions?
Any questions for Rafael? Okay, then I should ask at least one question as the chair. So, as you said, a lot of companies, they just want to use AI. They're not ready for that. Do you have any insights on how those kinds of companies, do they have some difficulties, for instance, regarding data privacy and regulations? Because when they depend on data, if they're not careful, they can also get in trouble if they misuse, for instance, personal data and so forth. Did you consider something like that in your research?
Yes, actually, it's a very big point, thank you, which I'm looking to the security, which is most important. Of course, we know SAP, we know CRM tools, and these most tools, they are really secured. Of course, where are you getting this platform from? And the reason why I really looked into that is I started my career many years ago as a customer service person, and it was a large company. So they inculcated AI in terms of our CRM tools and all that. But I realized that the customers were complaining because it was slow. It was supposed to be fast, right? But it was slow because it needs to pull up all the data and stuff. But for us, it's good. In terms of security, it's great. But the output to the customers, right, is declining. So I wanted to cover this gap. So answering your questions, of course, it's part of my research because it's one of the most important tools, and one of the most important things that needs to be inculcated, right? And many companies, the kind of checkmark I'm creating is part of it, right? The process is part of the security aspect, right? Okay, are you in terms of security? Are you ready to inculcate AI? Is a very big one, right? If yes, what are the kind of security in place? And then if you have it already aligned, tested it, all right, and ready to optimize it, then go ahead. Boom. That's it.
Thank you so much. Just a quick question. So you're on your second year of PhD. So what are your next steps in your research for this? Is some kind of, I'm guessing, introductory to intermediate research, but what will be your output?
My output again, next steps, to be honest, first I'm trying to create a checklist, like I said, for the companies, right? So when I have this, which I have created, and the next thing I want to do is now to see what are the results from these companies. Now, the companies that are really, going to run it with 1 or 2, 3 companies, and the results, then I start working on the results again.
So the forerunners for modern social networks were actually forums, which exist also today, but their origin is in the late 90s. Usually we can say that pioneers of modern social networks are, for instance, the networks such as 6 Degrees and some things which are now present in modern social platforms exist from the earlier examples. So actually, Facebook started in 2005, and in the first year, that was 2006, the number of users was 1 million. So Mark Zuckerberg, which is the owner also today of Facebook, actually started with his friends this social network on the University of Harvard, and it was mainly limited in that university. So currently, the number of Facebook users is approaching to 3 billions, and we are expecting that this number will be approached at the end of this year. So we can see here on this diagram we can see that the number of Facebook users is actually linearly increasing, not exponentially as we expect, but linearly. We are expecting that the next year the number of Facebook users will have actually the saturation. The reason is that nowadays we have another social networks which attract young generations. Of course, Facebook is not a charity organization. It's oriented to the profit, and actually here we can see the revenue of the Facebook, and we can say that it is now the market leader. What is also important for Facebook, that it is the takeover of the companies in that sector. For instance, Instagram, the takeover was in 2012, which is now also a very important social network, as we know. And WhatsApp, one messenger, also very much important, it was in 2014. And also another step is towards virtual reality of the umbrella company Meta, which includes Facebook, Instagram, and such similar platforms. So here is the revenue of Facebook. So we can see that the revenue is actually exponentially growing, in the contrary of the number of users. So actually here we have the important things such as data, information, and knowledge. Facebook uses different actually tools for data processing, modern tools, as we heard, for instance, in the previous presentation, like artificial intelligence, data mining, deep learning and also machine learning. Users can approach to Facebook 24 hours daily, 7 days a week, so that means almost constantly. And because of that, we have huge amount of data. For instance, in average, every user downloads 2 megabytes of data, which is equivalent to 1,000 text pages. On this diagram, we have different blocks considering data processing in Facebook. So here we have several, for instance, databases, deep analytic as one important block. Here I summarized the most important mechanisms of users' data collections, such as, for instance, psychological approach and technological approach, because we all of us are technology people. We as users actually share our data voluntarily, so nobody presses us to share the data. Facebook has different size of monitoring the user data. Some of methods are sophisticated, some might be not so sophisticated. So we have, for instance, on-site monitoring, which is obvious, and actually all activities performed by us are recorded, collected, and after that analyzed. Why our activities are analyzed? So the most primary reason is, as we heard in the presentation, in the previous presentation, because actually Facebook sells our data to different companies which are interested for our behavior. We know that today almost all of us has smartphones, and our activities on our smartphones, or more generally mobile devices, are monitored. As I told, a very important topic today is virtual reality. Because of different kinds of artificial intelligence, and what is also actual today are autonomous cars, autonomous vehicles, and they cannot exist without virtual reality. So, because of mentioned things considering data monitoring, what we can do to protect our data. Probably the most of users don't bother at all their data to be monitored. This is special for a young generation. They don't bother mostly at all. The most effective solution is don't use the network, of course, but we want to use social networks. For instance, we can use some security programs and to include add-ons. Then we should be careful, for instance, to use several different email addresses, and also more important, to use different passwords. I know that probably the majority of us use one password for different platforms, but this is not an advice. And also we should use some mechanisms for control permission on our mobile devices. So to conclude this presentation, I wanted to point out that social networks are now maybe the most popular means of communication, not so in our digital world. Facebook is now the leader in terms of revenue and also the leader in the number of users, but we suspect that it will be not the case in the near future, because the different social platforms could be more attractive, especially for young generation. So actually, the goal is to maximize the useful data, and more is more, we can say. The processes of collecting and processing the big data is actually not easy today. Users also should be educated about the mechanisms of the protection of their data. I know that it is sometimes difficult, and users don't have time to be educated in different mechanisms, but my opinion is that it is the most effective way. Okay, thank you very much for your attention. I hope that it was interesting for you.
Thank you.
Can I ask something, Professor? We saw that Facebook user accounts number is approaching 3 billion. Is there any research how many individuals are using Facebook?
I think I couldn't find that data because we know that some persons have several accounts, not only one. And I think that also maybe some methods of artificial intelligence or big data could be useful, but I couldn't find that data.
Are there any other questions? Okay, thanks.
Sorry, I would like to point out that Facebook doesn't have mechanisms to check if the names of the users correspond to real names. I think it is one problem.
It's not a problem. It's okay.
It's fact.
Okay, I just have one question. It was a really interesting presentation. It's always, well, I'd say fun to know what they know about us, all these corporations. So, for instance, Facebook is now part of Meta.
Yes.
And they acquired, as you said, Instagram, for instance, in 2012. But as you said, Facebook is not that interesting for younger people anymore. But they use a lot of Instagram, they use a lot of WhatsApp, because it's all a part of the Meta umbrella. Does Meta now know both? Can, for instance, can they exploit data from, for instance, Facebook to sell data from Instagram?
Of course, yes. We know that cases that all of data are actually merged.
Okay.
And I think that it could be dangerous because virtual reality. Meta now invests a lot of money in the problem of virtual reality because, as I told, for instance, for autonomous vehicles, which will be, I think, very, how I can say, very hot topic in the near future.
Hello everyone again. I'm Nemanja Zdravkovic, and I'm one of the co-authors of the paper of a comparison of Hyperledger consensus mechanism security and their applications. This was actually going to be the first paper of Sara Nikolic, our teaching assistant here, and she recently got her master's degree last Monday, together with Professor Franz, who is her supervisor, and another co-author also from SRF from India. So, what have we done, or what tasks we gave to her? The idea is to, because we all know different blockchains exist and different blockchains for different types of application exist. We wanted to find out more or less for Hyperledger-based blockchains, so enterprise level and private-based blockchains, what are their security mechanisms for their consensus mechanisms, and what type of attacks can be applied and how can we defend on this. So, just a quick outline. I'm guessing everybody knows what blockchain is, but I'll just give a as quick as I can be, an overview. After that, we'll talk about Hyperledger because usually blockchain is associated with cryptocurrencies, and we don't want that in this particular case. So, just to make a quick distinction. After that, the paper continues on attacks on blockchain. Although blockchain is presented as the most secure mechanism so far, it's also prone to different types of attacks. And we'll look at the vulnerability of the consensus mechanisms, which is one of the pillars of blockchain. And finally some conclusions. So, as I said, quick as I can be, a blockchain is a shared depend-only distributed ledger. Transactions, those are events, whatever they can be, are stored in linked blocks, which are called blockchains. So every transaction has a unique cryptographic signature, ensuring that the ledger is resilient to modifications. And because it is distributed, it relies on peer-to-peer networks, also relies on public key cryptography, and this distributed consensus mechanism. So, depending on the blockchain, but let's say all member nodes share equal rights. This is more or less an imperative on public blockchains. For private, not always, but for here we'll say just that all member nodes share equal rights. So this consensus mechanism, again, if somebody tries to add a block to the blockchain, so there will be a distributed consensus mechanism that says, okay, we've achieved the consensus, this block is added, we haven't achieved the consensus, a block is not added, and so forth. There are many consensus mechanisms, it's talked about in the paper, but for now I'll focus on the applications of blockchains. Usually digital currency, of course, Bitcoin and Ethereum and so forth, made blockchain a hot topic as it is today, but it's not the only application. Here are the most of the four pillars of blockchain use cases. Apart from digital currencies, we have a lot of things we're doing with, well, smarter blockchains that use smart contracts, a lot of security features, again, record keeping and so forth. Healthcare, for instance, as Professor Richard told us before, is a very large part of the blockchain community, but also, for instance, public sector like title records and so forth, ownership voting, also intellectual property and so forth. So, as I said, we are used to having associating blockchain and blockchain technologies, so in plural, but it's not Bitcoin, it's not Ethereum. And we will now be focusing on mostly Hyperledger, which is an IBM and Linux Foundation community. They're kept up by those two entities. So it can be both private and permissioned. So nodes are not publicly known. You cannot just enter or join a private blockchain. It can, but it usually doesn't have a built-in cryptocurrency. It can have some other mechanisms. It uses a lot of different consensus mechanisms depending on the Hyperledger project itself, while Bitcoin uses proof of work, Ethereum proof of work, and proof of stake, and so forth. And again, different types of technologies used to build blockchain applications. So something about Hyperledger. So just to make it very clear what the difference is. It's an open source community hosted by Linux Foundation, IBM also. Again, focused on developing a suite of stable frameworks and tools and libraries for enterprise-grade blockchain deployment. So we're not talking about cryptocurrencies, which is also a good thing, because we'll see later on that most of the attacks are actually based on, or not based on, but they are connected to cryptocurrencies. Again, it has a modular approach to hosting projects because participants are known to each other, because they have a shared interest in participating in the co-consensus process. This makes it easier for the consensus mechanism itself to be less computationally heavy. So for instance, proof of work is very computationally heavy, but if participants are known to each other, which means some level of trust is present, we can take the load off the consensus mechanism itself. So this allows us to share data with a greater degree of security without the need of this computational heavy mechanisms such as proof of work. It has its use cases, we'll talk about that also, but for instance, for now, we just put it aside. Again, enterprise solution, high performance, high scalability options. Hyperledger is an umbrella term. Most of they're called not blockchains, but distributed ledgers. It's the same class of technology, but private and public are distinguished by that. Again, it's just a term, but for instance, Hyperledger Fabric is the most well-known Hyperledger project. But there are also, these aren't just the only ones. For instance, Burroughs after that, Indian, Roca, Sawtooth, and Besto, but they all have their different flavors of Hyperledger. Some of them more for mobile applications, so for edge devices. Some of them are both permission and permissionless, I mean private and public. They support Ethereum, for instance, and smart contracts and so forth. Burrow as well. But besides the Hyperledgers themselves, they also, the distributed ledgers themselves, Hyperledger also provides a set of libraries, set of tools to make developing distributed ledgers a lot easier. And we will see here just, for instance, what are their applications and their consensus algorithms that they use. More or less, you cannot see here proof of work or proof of stake. So most of them use different kind of consensus mechanisms. Some of them are more computationally heavy, some of them are not at all. Some of the projects don't need to use a consensus mechanism in that way. They have something similar, let's say. But depending on the type of project type of solution that we're interested in developing, we can choose some of these consensus mechanisms. For instance, we see Fabric has both Kafka and Solo and Raft, and Sawtooth has this again, 4 types of consensus mechanisms, or you can build your own in some cases. The idea here is not to be similar to cryptocurrency blockchains. And the idea for the rest of the paper, because all of these consensus mechanisms are explained in detail, the literature is extensive, and we wanted to provide a review on the attacks on both these types of mechanisms, but also the most common ones as well. So the rest of the paper deals with types of the most common attacks or vulnerabilities to the blockchains or distributed ledgers based on consensus. Of course, the DDoS attack is the most common one. 51% attacks. Well, I will explain every type of attack here. Long-range attacks, P plus epsilon attacks, and, well, a group of attacks or a class of attacks which is called Sybil attacks. So I guess we all know what a DDoS attack is in general, but in context of blockchain, it will focus on the protocol layer of the chain itself. The biggest threat is transaction flooding. So because blockchains deal with transaction, it can be anything, but a DDoS attack, in this case, a node will flood transactions to the blockchain. And it will spam with false transactions, and then will compromise the availability of the original users or the real users, and again, to have this undesirable impact on the network. What are the most vulnerable consensus mechanisms for this type of attack? Proof of work. Nothing is used here, proof of work, but again, most of these attacks, that's the conclusion, but most of these attacks are actually targeted to cryptocurrencies. So enterprise level blockchains are even secure in that way as well. Proof of stake and delegated proof of stake, but Raft, which Fabric uses, can also be vulnerable to this kind of attack, and proof of authority as well. What is the solution that has been, well, filtered out through the reviewed literature is actually transaction filtering. So a mechanism that will filter transactions, again, based on either node IP address or some kind of other mechanisms, also, not also, but almost always in conjunction with machine learning or some other type of filtering of transactions to point out the nodes that are flooding the blockchain. Actually, this is the most common type of attack, or the common type of threat, but it's hard to implement. Because it's a distributed network, when a node or a group of nodes controls more than half, then it's centralized. So the idea is not to get a miner or a group of miners, nodes, to control more than 50% of the network and the blockchain. This type of attack is very dangerous because it's not detectable until it's too late, and if organized correctly. Again, proof of work, proof of stake, delegated proof of stake, Raft are the vulnerable mechanisms that are susceptible to 51% attacks. These are more susceptible than others. And the solution, well, there is no complete solution, but the larger the network, the less unlikely it is for a 51% attack to happen. For instance, in the blockchain, in the Bitcoin network, I think a successful 51% attack would cost around, I think, $2 billion or $20 billion. Either way, it's in $1 billion. So for larger networks, it's very unlikely to happen. It can happen for new cryptocurrencies, for instance, which are being developed almost every day, but for stable networks such as Bitcoin or Ethereum, these types of attacks, they exist as a threat, but they still aren't hopefully they aren't up there. Another type of attack is long-range blockchain attacks. It's similar, but we're talking about blockchain forking earlier today. So, for instance, a blockchain can be took over with a false chain, which can render previous blockchains and previously blocks in a previous chain invalid. This is very vulnerable mechanism is proof of stake. For instance, in Bitcoin, where you have proof of work, a block is added every 10 minutes, and the difficulty level is adjusted, so every block can be added in 10 minutes, more or less. For proof of stake, for Ethereum, this addition of new blocks to the blockchains it's a lot shorter. So it's less likely to be identified when a chain can have a fork with a false chain. What is the solution that we have identified? Something called bootstrap nodes. These are nodes that are trustworthy, let's say, and they can always initiate in addition to the chain some checkpoints. So after a number of blocks, this checkpoint block or checkpoint transaction within a block can say, okay, this is valid. And we have something called a range of blocks that can always consider to be true. For instance, we have 10 added blocks to the blockchain. When we add the 11th, then we'll say, okay, the first one is validated. I use these types of practice exam for my students for my blockchain course. But this is one of the solutions for this type of long-range blockchain attacks. Another type of attack is this P+epsilon attack, which is basically bribing other nodes. So influencing other nodes that they get incentives from the blockchain. The attacker can promise to pay P+epsilon to all voters who vote for their solution if that attacker's option is selected. So this is a general problem, and it's well known, but systems such as blockchains are very susceptible to P+epsilon attacks. So proof of work, distributed proof of stake. The only thing which is considered a solution, it's hard to implement the attack because you will have to have a lot of, for instance, stake in the network if you're using proof of stake and to know the nodes, but this is targeted to public nodes, so it's very hard to implement. Finally, a class of attacks, maybe I should start with this one. A Sybil blockchain attack. So when a single node makes a fake identity, so a single node can make more false nodes at the same, for instance, IP address or something. And then a Sybil attack can, for instance, block users, perform or try to perform the 51% attack and so forth. The thing is, all mechanisms are theoretically vulnerable to this type of attack. And another layer of security has to be added, for instance, two-factor authentication or node propagation modeling or something like that. These are the identified solutions for this type of attack when a single node can make a lot of fake identities. So, what are some conclusions that Sarah was doing the majority of this paper? So she said that more or less any type of blockchain, and before the consensus mechanism is used, is vulnerable to at least some kind of attack, or at least to this theoretical Sybil attack. However, we have a silver lining that attacks are mostly focused on blockchains that are public and that are used for cryptocurrencies. And the identified solutions in this review paper were either combining two or more consensus mechanisms. That is something that can be done in Hyperledger. We can have node segregation, so again, having trustworthy nodes. We can have an additional cost for a node to be added in the blockchain, which is again done in private blockchains. Node behavior monitoring, similar to what Professor Guy told us in his network analysis. It can also be implemented in node behavior. And as a final conclusion, because it's about Hyperledger, it's using private blockchains, that is private distributed ledgers, for the solutions that we want, because they can provide a much more flexible and easier to implement level of security that are less vulnerable to all these attacks. So when the proceedings will be published, you will see all of our literature review and identify the attacks in detail and the solutions in detail. So, thank you. I apologize that Sarah couldn't present this paper, but she is having classes now, so next year I hope. Okay, any questions? Yes?
I would like to ask you, you told that one advantage of distributed ledger technology is because of this chain of blocks or nodes. And if you told it that if we have attack on one block, so it doesn't bother the other blocks, as I understood you.
It depends on an attack. For instance, we can have a typical DDoS attack which just disrupts the network and no blocks can be added or validated and so forth. We can have false transaction flooding. So for instance, a lot of nodes can send their transactions to something that's called a transaction pool, which are invalid transactions by themselves, but also that can disrupt the network because it uses the processing power of other nodes. We can have, up until the last validated block, it will be secure. But if the attacks are from the last validated block to the remainder for the formation of the next blocks, those are the types of attacks that can be done in blockchain. So we have 5 nodes. These 5 nodes are okay, but attacks for the 5 blocks, sorry, for the 6 blocks, for the 7 block, and so forth. So those are the concerns of blockchain attacks.
And my question is actually, would be the efficiency of those attacks lesser when you use more blocks?
It mostly depends on the, if we use more nodes, like nodes, it's harder. Yes. Or use a different type of blockchain or distributed ledger in the first place, like Hyperledger, where it's not public, it's private, it's a closed circle of nodes. And in that case, there is a level of trust, a larger level of trust compared to public blockchains. So we can expect trustworthy nodes that don't make attacks. Then we can do it with smaller number of nodes. For larger networks, the larger the network, it can be harder to implement, especially 51% attacks.
Thank you.
Okay. Yes?
We have blockchain technology as one of the most fast-growing technology, and also one of the safest technology. And on the other side, we have attacks. Do you know how blockchain technology is resistant to this attack? We have optimistic results, or to continue with blockchain, or we have some new similar technology?
Okay. Okay. First of all, blockchain is not a single technology,
Yes.
but it's a class of technologies, and some of them are less secure, some of them are more secure. That's the idea. It's still a new technology. It's still in its infancy, so there are some. It's getting implemented more and more, but for a really global scale of implementation, besides cryptocurrencies, it's still not researched so far. Any type of system is prone to attacks, but so far, blockchain is optimistic because the immutability of the data. But well, I can say time will tell, but I wouldn't be doing blockchain research if I don't believe that because it really is a disruptive technology. The next iteration of the internet, Web 3.0, one of the pillars will be distributed networks. Will it be called blockchains or distributed ledgers? It will most definitely be implemented. So a positive look.
For now, are we have big losses in data according to these attacks?
Again, it depends on the attack and on the blockchain. For instance, if we have these transaction flooding, there can be loss of data because we have a lot of invalid transactions incoming, which can render the good transactions not to be processed. But again, it all depends on the technology itself. The robust the consensus mechanism, it will be less prone to attacks. Proof of work, however computationally heavy it is by design designed to be very hard to attack. But we use a lot of power. Usually, I put a slide how many kilowatts of power and how many carbon dioxide emissions one single transaction for Bitcoin is used. So it's good in a way that's secure, but it's bad for the environment because we're losing a lot of power, electricity, processing power. So the idea is to find something which is, again, secure, but less computationally heavy and more green.
Yes, this is a new technology, and today, for now, its main goal to cryptocurrency, but it can be find application to signal processing, for example. And this is just the beginning.
Of course. This morning we had several examples by our keynote speaker, especially in medicine and the public sector and supply chain management. I would truly believe it will be the standard in maybe 10 or 15, 20 years. It will be something as QR codes are today. And blockchain will use QR codes as well. Any other questions? Yes?
Quick one.
Mm-hmm.
Utilization and application of this technology, is it dependent, or in fact, is it in the shadow of cryptocurrencies?
Unfortunately, it's still a synonym. So when we say to a non-technical person, you say, okay, or even a technical person who's not into blockchain technologies, plural, they say, okay, it's cryptocurrency, it's money laundering or something. But the community which is using blockchain for other purposes, that's because it says hyperledger and distributed ledger, we want to differentiate ourselves from blockchains which are still, unfortunately, tied to cryptocurrencies. But the underlying technology itself can be applied for, as I said, a lot of use cases, and it shows promise.
Do you expect it to change in the near future, to distinguish between?
I think not, but not in the near future. But I'm guessing that, for instance, Ethereum it is cryptocurrency, but it can be used for other purposes as well. So I think either it will be Bitcoin and blockchain. So Bitcoin for all cryptocurrencies and blockchain for all others, or blockchains and distributed ledgers. So, but as I said, time will tell, at least for the terms to differentiate.
Dear ladies and gentlemen, thank you, dear professor, for introducing me. I come from the Belgrade Metropolitan University, Faculty of Information Technology, and I co-authored this paper together with a colleague from the Faculty of Technical Sciences, Department of Computer Science and Technology from the University of Pristina in Kosovska Mitrovica, at Trnjević. Our today's topic would be towards creating methodology for a cloud container assessment, security assessment, and an overview of available tools, as you can see. And what I want to point out at the start of this presentation is that we did, this is only one part of our research paper that we are planning for publishing at a SCI paper, as an SCI paper in an international renowned journal, and we did an overview of the current sample that we had on the within the interviewees that we had interviewed for cloud security. We'll get into details very shortly. What we wanted to point out in the introduction of our paper is that there are several risks when transferring from conventional technologies that used to deal with security into the cloud realm. And this is the most popular way of making the containerized workloads, such as the tools such as Kubernetes from Google, so the GKE, and we have also the Fargate and OpenShift as some kind of open source solutions that kind of give us a possibility to advance in this field, not only to use the commercial ones. Although I must say that Kubernetes is the leader as an orchestrator right now, and most of our interviewees within the sample have dealt either with Kubernetes or with common, most, so to say, advanced cloud providers such as AWS from Amazon. Nonetheless, that doesn't mean that they are the most indicative for the cloud threat security problems. That's what we wanted to find out in the outcome among our sample of the questionnaire. We have some, in the introduction part, we analyzed the cloud architecture, and we determined the way in which we have the relation of the cloud and security in the cloud, mentioning the conventional architectures. And our aims is to analyze the work which was related to cloud environments by analyzing the literature, analyzing the references, which try to suggest some kind of models for dealing with cloud security threats, and to see to compare it with our results from the questionnaire, and to see what are the next steps that we should do. What kind of sample do we need? What kind of questions do we need to ask our interviewees in the future to get some kind of towards the methodology for creating or assessing the cloud container security. One of the things is that one of the papers that had dealt with this subject was done by Samko at Altry. So it had indicated a creation of the cloud-safe platform, and this study focused on AWS. So again, so we cannot say that it's for all cloud providers such as JKE, for example. One of the other studies from Mita Shri et al. Said they proposed some kind of a three-stage model for data security in the cloud computing. But at the outcome of our comparison between these studies, there is not a concurrent methodology for assessing. It's either one side of the coin or the other one. It does not deal with some kind of a common framework for assessing cloud containers. This is what was our motivation and for analyzing what we did. We analyzed, we made a survey which can be seen on this sample here. So we focused on understanding challenges and opportunities related to spending to cloud environments and other related issues in the IT world. So we had some 30 questions. And we had the questionnaire sample involved 29 members of the IT sector. So with one kind of prerogative is that they have to have dealt with the security in some part of their career. They are IT specialists. They are in the companies or the academia, but have been dealing with this topic, or at least are familiarized with the topic for at least 1 year. As we can see on the next slide, we have a sample. So this is our sample. We have 29 interviewees, so basically 17% of them had 0 to 10 years experience with cloud technologies. We have 24% that have 10 plus years, so more than 10 years experience with cloud, and most of them, 31%, are either the ones that have 0 to 10 experience, 0 to 10 experience in general in the IT world, with 0 to 5 experience with cloud technologies. So most of our sample includes the experts that have been dealing with cloud technologies for more than 5 years, and most of this sample for more than 10 years. So we consider it valid. We will continue, we'll make a discussion on the results. What I wanted to say is about the results, there is a low level of attention paid to the security in the cloud environment. So this is a question showing what are the most common, for example, depicted in the house. I didn't mention this one: software security, server OS security, PC operating system security, or cloud security. Which one is highly important? One is less important or none, and 5 is of greatest importance. As we can see, software security, when it comes to cloud security, most of the interviewees responded that there is not a significant, to our surprise, that there is not a significant need to deal with cloud security. And we find some kind of a breach in this, where we can focus on further going into our research to make it methodologically more sound in the future research. So this is the second one in saying what are the most indicated cloud threats and services. We have the proliferation of security issues, such as confidentiality, availability, usability, non-repudiation, not turning, so to say, and integrity of the system. On the next slide, we have security vulnerabilities in cloud environment. We have different modes, different reasons for having security cloud attacks. So we have third-party apps, and we have ransomware, out-of-date apps, and operating system vulnerability. But we have indicated 13 respondents answering almost 45% that there is out-of-date apps, and significant numbers of other and inadequate policies. In the very last slide, we have the outsourced data and services in the cloud. They are the subject to the risks. And we have some security patterns. This is an overview of some kind of so do we need to, the question was, do we need to scan the image before publishing it or making it work in the final version? So most of the respondents answered with some kind of 4, which is still not significant, and only 11 interviewees, or 38%, answered with this highly important. Of course, most of the answers in the lower region were logically that it's not at all necessary, was indicative, so that it's not true. As a final conclusion, we need some analysis of an international sample. So our sample is within 29 interviewees that we had interviewed. This is no worry, this is not a security alarm. So just for my conclusion to be ended. And so we have some interviewees that are based in other countries. We must say, we must kind of emphasize the fact that 29 interviewees have been employed by international companies. So we can consider our sample international, but for some kind of methodological scientific reasons, we want to have an international sample which we can compare to our Serbian sample and then see if there are differences. If there are no significant differences, we'll proceed with creating some kind of globally indicative methodology for our research. And so, of course, in the future, we also need to say that the comparison of the results with the literature, which we found at the beginning of the presentation, show that there is a real cloud threat incident analysis which is needed and necessary to get more specific results. No matter how many of our literature references tried to develop some kind of models which were purely theoretical, all of them, there is a consensus, and also this is this is reflected in our survey also, that there is a need for a real analysis. We cannot say that something is secure just because we made some kind of theoretical model. All of our respondents agreed upon this fact. So I would like to just want to thank you for your patience and enjoy the question.
In Federated Learning, we have local machine learning data, which is then translated into the local models. So when it comes to data, does the data preparation process differ or not so much?
Well, first of all,
in general.
First of all, I would like to emphasize the role of machine learning in cybersecurity and generally. Machine learning is really a very popular approach and a strategy to solve many real-world problems, including cybersecurity and cyber attacks and so on. Machine learning is an old discipline, as we could say, but during last decades, we can witness the big rise of this field. There are many factors that contributed to the rise of machine learning, if I can say so. First of all is hardware that really became very strong and powerful today. Second, we now have very fast internet, and third, and also very important part, is data storage. Many companies earlier had to pay a lot to store a big amount of data, and now that's not the case. It's very cheap to store the data and manage the data. So all these factors contributed to the situation that we have today, and that is availability of data to the companies, to the scientific institutions, and like never before, we can analyze and manipulate with data on everyday level. Yes, of course, data preparation is one of the, if I can say, unavoidable tasks in the machine learning process, and it is very important to do this properly. As we learned during our educational part of machine learning that if you don't have good data, you cannot expect good results. That is the thing that you hear when you learn the theoretical concepts, but when you go to practice and really do on some real-world examples and real data, then you really realize how important this is and why is it important to do good data preparation in order to get good results. There is a term in literature that anyone can find, and that is garbage in and garbage out. And even that is very simplified, it is the essence, really. Nowadays, you can find many new and fancy machine learning models and algorithms, and people are doing research worldwide about developing these kind of algorithms, and that's really great. And we can see many scientific papers dedicated to the solution to many problems that people couldn't solve so far. There is really, there are so many problems that machine learning now can solve. Earlier, we talked about supervised and unsupervised learning, and something that Professor mentioned was reinforcement learning. That was something that people were only imagined that will happen, and now it is happening. We are witness of using of reinforcement learning in the real world applications and
the robotic applications.
Yes, and it is totally incredible what now reinforcement learning can do. I don't know. Last week, Facebook and Meta, that our other professor mentioned, they pointed out that now with reinforcement learning and with natural language processing, they
it's more suitable, more dynamic environment.
Yes, they learned agents to be at human level for a diplomacy game. They named it Cicero, and it is really breakthrough in artificial intelligence. So really, we are witnessing one new epoch in technological really breakthrough and rise. Things that we couldn't imagine before are happening now. So yes, we use the data. Every click of the mouse is data. So it is really a tremendous amount of data that we can use and manipulate with it. And of course, there must be precaution. There is always the other side of the medal. Yes, we can use this data for things that are not good.
Yes.
We must talk about data privacy. I will again mention Facebook and social networks that use the data on everyday level. And I will go back now to Nema's question. That's data preparation. I spread the story. But yes, we must pre-process our data, and then we must extract the most important features in order to have a good model and great accuracy. And if we want to deploy that in practice and in real time, we really must dedicate the most part of our time will be dedicated to the data preparation. And less time we will spend on training and model picking.
It's already models are available.
Yes, there. It is maybe it is also for discussion. Is it good that today now we can use machine learning models as black boxes? We will just call. We have really a very great libraries in
Yes,
Python.
4 or 5 lines we can produce.
Yes.
Only 4 or 5 lines of code.
We just type this model, that is black box.
Yes.
We have input, we have output, and great. But it is really important for people that are in this story to comprehend very well, at least intuitively, how machine model works, and not just to call it as a black box. And of course, I said it's easier part. Maybe I think that the tricky part is good data pre-processing.
Of course. So, add up to her point, as Manja pointed out, federated learning, what is extra care we have to take for data preparation, right? So, federated learning is distributed learning, you know that. Here the idea is we want to utilize the variability of the data available across the different places so that my model will be developed in a robust manner. So for that, we should take care that the data in individual local training should be independent, non-identical. That is very important. So while preparing the data for federated learning, we should see that our data, local data, is unique. It is not dependent on others' data. If you produce similar data, no new knowledge will be generated. I am collecting a model from n number of nodes. Each model has to be exposed to different type of data. They should not be identical. Then only new knowledge will come from every node. Then only we aggregate all the new knowledges. I will get a super duper knowledge based global model. So while preparing the data, we should see that those data from different point will independent or non-identical. That is a care we have to take care when you are going for preparation of federated learning.
Okay.
I hope I answered your question.
Yes, of course, of course. And now I have a follow-up question.
Yes.
So, as you said, unique data, non-identical to get better results.
Yes.
To keep the global model improving and more robust.
Yes.
So, what about when we're talking about sharing of the data? Usually, individual local data is not shared. Do we have some examples, maybe some use cases in federated learning? For instance, if we have, I don't know, 5 nodes, 2 of them are willing to share, but 3 of them don't want to share. Is there some approach to which is for this type of model, or they just agree not to share even if they want to share?
Okay, is it good to share data? That's okay. Okay, even some nodes are sharing the data. We have to dedicate some computer to train those data models. So again, it may be done in centralized education, but what is a new extra thing we are going to get? Nothing. Having the data, we don't have nothing. We are not going to generate anything new. So it is immaterial. Even I get the data or not, it will not make any sense. I will get model. I am interested only model under federated learning. Having the data of somebody is what is the use for me, unless otherwise I am not misusing it. So it is advisable not to share. Why we need to share under federated learning? Because we require model.
Thank you. So only the model is required.
Yes.
Okay. That is federated learning, and
yes.
A subset of federated learning, we said distributed learning. This is within one organization, but on different nodes, right?
Yes.
Okay, and in that case, they usually can share the data.
Yeah, of course they can share under that concept because they are a single organization. They can share.
Okay, and when it comes to we saw a lot of examples, for instance, for medical applications.
Yes.
Then I'm guessing there are a lot of regulations that has to be employed in order to have the data processed.
Yes.
At first. So can you tell us if you have any example? What were the difficulties of, for instance, in India it's different than in Europe or in America with GDPR and HIPAA standards. What, if you can disclose, of course, what were the difficulties of preparing the data for these medical use cases, for instance, if there were any?
Okay. So actually, in different places, different regulation. That is the issue actually. So sharing the data, there is no uniform regulations. That is a very difficult thing in medical field. But medical community will get benefited only if they share the data to make a global model. So that is the reason we are bringing to a technology called federated learning. We no need to worry about the regulation of data sharing and the boundaries. Whatever the regulation locally they have, let them to have. We are not going to take any data, we are going to take only model. Of course, maybe during the deployment of the federated learning, there may be some regulation, new regulation will come into practice for sharing the model also.
Okay. Okay, thank you. So far we have no worries about sharing the model, but perhaps in the near future we will have also regulation for sharing the model as well. I wouldn't be surprised if that was the case.
Yes.
Okay, thank you. And my next question will be towards Professor Kisic. So when it comes to, you talked a lot about data preparation. We know that you have worked as a data scientist, so could you tell us a little bit for those of us who aren't in that field, what are the, well, if you get raw data, any type of use case, what would be the steps of getting it ready to input it to a simple machine learning model, for instance?
Of course, Nemanja. First of all, the job, if I can say that, of data scientist is to analyze the data and to get insight of what's going on. It is very important for people that are involved in this story to have domain knowledge. That is very important and maybe sometimes a neglected part because if you do not have good domain knowledge, you cannot solve the problem. That is very important part of the story. If you want to work on some medical problem and you're an engineer, you must consult people from the field and they must share the knowledge and their competencies so you can really have reliable conclusions for the problem that you're solving. That is the first part of the story. When you get the raw data, you must, there is usually some process that is more or less common to all the data science strategies, if I can say so. You must analyze the data you have. You must, that is something that we call explorative data analysis. You must explore the data set that you have because usually you have some historical data set, some collected data that you will process and then will extract some useful information. So you must analyze the data set that you have and when I say analyze, you must do some statistical analysis to see what is in your data set. Do you have some missing values? Do you have some non-values? Do you have some kind of noise in your data? There are many kinds of noise that the data can have depending on the way that depending on the data and how someone extracted the data for you. There are usually two scenarios. In one scenario, you will get the data from the usually client that is asking you to solve the problem, or you will have the task to provide the data by your own, by some web scraping, or I don't know, some measurements, recordings, depends again yes, on the problem that you are solving. So you must remove the noise from your data, remove outliers. You must be precautious because sometimes outlier will tell you something more about the data. That is sometimes tricky part. So you must perform very detailed explorative data analysis. And you must, as I say, handle the data. Sometimes you must perform normalization, standardization of the data so that your machine learning model will not waste the time and energy, if I can say so, on the unprocessed data. And when you finish all that, and that sounds pretty simple, but in practice it's very often the hardest part because that part of data analysis is very often the key to the problem you have.
Yes.
And if you don't do that properly, if you do not prepare your data and analyze them well, you will not have the insight in your data, and that is what data analysis is. You need insight of your problem, yes. And that is the part of the data science. Part of machine learning is to make predictions. And sometimes people are confusing these terms. data science, machine learning, and artificial intelligence. Although machine learning is a subfield of artificial intelligence, there are differences between these areas. Data science will analyze the thing and get to us insight. Machine learning will make predictions, while artificial intelligence will lead us to the point where we have actions. And together, they will make a really good story. We must connect all these fields to solve the real world problems. It is easy with toy problems. Those are toy data sets that people are learning, but when you come to real data that are
Real problem.
from real problems, those are problems that people really tend to solve. And when we need a really big accuracy of our model, more than 99%, not 70 or 60, it's not some student's project, it is a real world problem. So yes, I will come back to Nemanja question. We must pre-process the data as the way I described. Of course, there are so many things that we can do with data, but basically that's it. It's explorative data analysis. There is also expression, extract, load, transform the data. So we must do all that to get good results from our model.
Yes, yes. To emphasize her point, I want to share my stories in developing a product, wearable product for continuous glucose monitoring of diabetic. We designed the sensor and we capture the data from the sensor as a raw data. We just applied the data to machine learning models. We saw only 30% of accuracy.
Oh.
Then, as Emilia said, we sat and did exploratory analysis. Why? What is the problem? Why this data is not giving accuracy? We have done many exploratory analysis. From the analysis, we come out the data are very highly nonlinear. Any linear model cannot be able to solve those. Then we tried some nonlinear model, and it's increased the accuracy to 30 to some 80%. It's fantastic, but still it is not enough for practical deployment of product, that too medical field. So again we sat with the exploratory analysis on the raw data, and we did a lot of transformation, as she said. We transformed the nonlinear data by using various transform mechanisms so that the data will become somewhat linear, and we have done some data cleaning part, and after that we are able to end up 98%. So that is the power of data cleaning, data exploratory analysis, as she said. So it's not like you just get the data, you apply machine learning model, you will get the result. As she said, we need some exploratory analysis, mathematics, statistical analysis. Then that too, we need some visualization too, to visualize what is happening in my data. And with the help of visualization, we can infer some insight about the data. Then we can develop appropriate pre-processing model. Then after pre-processing and transforming, scaling or normalizing, if you feed the data to machine learning model, it will give good performance. That is what our observation practically when we are dealing product development.
Thank you. Thank you. It's really insightful to know, as both of you said, it's one thing to just have the data and run it through the model, but it's a totally different problem to pre-process the data and then find the properties of the data and then apply the correct model in order to get a better model. Yes, a better accuracy.
Yes.
Okay, since we're since we should start the second session, I will just have one concluding question regarding to federated learning. So we have collected our data locally. We have managed. We have trained our models, and now we have to aggregate the model to a global model or to a central server. What are the steps and what are how to improve if we have some models that are more slow, for instance, or is there some kind of averaging, or taking out the least favorite models or something like that. So in federated learning. So Professor Vijay, maybe you can answer that.
Yes, of course. Okay, so by default mechanism for aggregation is averaging. And one drawback on averaging is it will be biased. I will not get good picture performance most of the cases, unless otherwise all the models are more or less near to equal performance. If the models are having drastic different performance, averaging mechanism will not work out. You can see that suppose the student is, let us take 3 students, one is 100 mark, another one is 90, another one is 0. If you average it, what will be the value you will get? 190 divided by 3, how much? Roughly 60. You see, I say average performance is 60, but one of the student is 0. So average will not work out many cases unless otherwise they are more or less equally performed. So under the circumstance, we go for some other tricky algorithms to combine or aggregate, that is accuracy based. We can try 1 or 2 sample data, each model, what is the accuracy they are producing. Based on that, we can give some weightage while aggregating. Weighted average mechanism could be helpful for that. So I can give more weightage for more accurate model, less weightage for less accurate model. Like that I can do. And another aspect while aggregating, I want to handle the malicious or attacker also. For that, I can have a trust value. I can monitor how they are giving a good model or not. I can have a trust value. Using this trust value, I can do aggregation, weightage also I can give. So more trusted node, I will give more weightage while aggregating. Or I can go for quality of data based. I told that already. All nodes should be non-identical data. How the data are more non-identical. That means how they are far away from other data. Based on that, I can decide the weighting factor for individual model while I am aggregating. So like that, lot of strategies we can apply.
Thank you. And just to conclude, do you see federated learning as something that will happen more and more in the future?
Yeah, definitely. Of course, you know that we are living in the big data era. Huge amount of data are available, and these models are going to provide only good performance if you apply more data. And applying more data, we have already discussed that it's a problem to sharing of the data, and also handling huge amount of data in a single point is very, very tedious.
Yes.
So considering these 2 factors, definitely there is no other choice for implementing big data analytic based machine learning mechanism other than that of federated learning.
Thank you so much. Thank you both to you, Professor Vijay, and to Professor Emilia for this a little shorter roundtable, but nonetheless I hope we learned something more about data and also data in federated learning. So I'm hoping that there will be at least 2 papers next year in federated learning.
So sure, that too with the data analytic framework.
Okay.
We also hope.
The technologies are entering both the digital and the objective reality. Nowadays, the cyber threats are really challenging the world that we need, not just infrastructure, with communications, future weapons, smart homes, cities, and the biggest question here is whether in the future the artificial intelligence will govern us, or we are going to still keep the control.
I'm sorry, Professor. We just see the PowerPoint program. We don't see the full screen. So maybe.
This one okay?
Okay. Now I see the first.
So going further, the technological and objective reality clash is creating a new metaverse that is actually joining the realities through different assets of communicating and creating both technological and social challenges that on the very clash are creating a hybrid one that require in a way balance between regulation, transformation of the culture and reality, parallel existence that we nowadays see with the social networks and technologies gap that
filled with Internet of Things and foreign pendings and values. And within this context, phenomena like social engineering, information flooding and overload, attention deficit, social changes that are actually very observable due to the pandemic that has been a lot of augmented, have to meet the technological progress of autonomy, innovation, scale and speed, adding the role of the artificial intelligence in a way that is inevitably targeting the post-information age of knowledge, where the computers are going to process and in a way give an advancement of our senses and cognition. And in this context, actually you can have both positive and negative scenarios, but obviously one thing is for sure clear, that the situation is in a way quite ambiguous, so you can not neither say that the future will be positive or negative, but here you can see just a study that we organized this year within a summer school with young generation, and I would like just augment this part. What they say is a major negative, okay, negative moment. So that the duality of artificial intelligence, collapse of the future society, major changes in the moral values, manners, and also trust in the technologies. Of course, there are numerous uncertainties here, and when we talk about cyberspace, these uncertainties are quite interesting, especially towards the society 5.0 concept that is taking the unpleasant stuff to the robots and to the smart technologies, and we the people are addressing more creativity. That's one. But going even further, to society 6.0, where it is expected towards year 2050 to understand the future in another way that takes some governance role to artificial intelligence and robots, the situation gets even more challenging. So how to cope these new reality expectations for the future? So we propose a multi-perspective approach towards the future, ethic modeling, by using expert assumptions and references, and further trying to assess these expectations with some simulations and observational models that are joined to the human factor in the problems. So you have both the experts and the focus groups that are trying to, in a way, assess the future. So this is a really very new scenario matrix that we updated with a plausible scenario futures. And within our study, we have more than 100,000 scenarios, but this time we add also the implausible one. This one scenario combination is adding a driving factor of smart innovation, digital changes of social behavior of the future, leaving parallelism as an adversary, dividing the world with adding implants through transhumanization, and this creates a new opportunity of mixed ecosystem, but in a way ambiguated towards future technological and social growth that is actually contradicting with human-machine clashes. So this is just one of the scenario combinations that has been discussed in the book from more than 100,000. And the idea is here to add the plausibility. So these things that we cannot accept or become true, but actually they exist according to reference data that we use. And this very first multi-dimensional approach is actually creating a seven-dimensional picture that in a way is very difficult for our imagination. So for handling this, we continue with the system analysis, and here the situation is a little bit different. So you have both social in yellow technological in blue, and also assets. And together with this, we have some other active moments towards in the red that are concerning smart governance, this hybrid joining about the security, and of course the one that are not quite clear, but the white gaps are in white color here, like reality mixing, internal system drivers, external impacts, etc. And at the end, you get this exemplary classification that is classifying the object between perpetual and intermittent exempt by means of effectiveness towards the future. And this is one just scenario are set of this 100,000 scenario combination. So this is just a very momentary snapshot that is showing that in the future advanced robots and avatars that are colorized here in red together with transformed people will be quite not easy for forecasting towards their behavior. And in the boundary, you see future external impacts. They are here colorized again in red number 14. This is entities are in a way not quite easily defined between these two classes. And because this is just assumptions and guesses towards the future, so on each of these relations, get this 100,000 scenario combinations and above, we need to proceed with the supercomputer simulation of the reality. So you cannot work just with the experts, but we need to add here the supercomputers. And what is new here, that due to the pandemic, the stochastic approximation that we are implementing in the quadratic forest of context, and have a strict, in a way, kind of cyclic dynamics starting from prosperity, recession, depression, improvement, can be modeled with these social jumps that we assume to be existing in reality, and we can move from prosperity directly, for example, to depression, to another improvement, but it's also a possible scenario combination. But unfortunately, this is quite complex one to be explained with just a few slides and words. But the idea here is that we use some quantum physics approach that we can model each of these relations in this way, and we have a supercomputer quantum simulator or a quantum machine, we can understand better this kind of classification dynamics. So this is not just a picture. It's a lot of calculations behind. But in the end, I think this one is more illustrative one about these three entities in our model that, for example, are giving an effectiveness quantitative value in the context of digital lifestyle, reality mixing, or embedded Internet of Things. What is most important to note here is one fact that actually this is system dependent. If you have other entities that are not in the model, and you can understand about this by adding the human factor observation or perspective, with our efforts we can extend with the machine and human intellect joining the model that we are using, both with the system intellect and within the logical analysis. So going even further, we have this kind of verification approach that is adding multimedia and biometrics, but I would be interested if this can be, I'd like to test if this slide especially is visible. Just let me know, Nemanja, is it possible for you to watch the videos?
I think yes. I think everything that you put, we can also see.
Okay. So in a way, I move to this slide. Actually, we have a virtual reality lab where you are able to stimulate with a multimedia, especially prepared scenarios about the future, our mental cognition state, and we are able to measure to what extent you are able to assess using different biometrics about peripheral and central nervous systems towards these futuristic scenarios. And going even further, we enter your sleeping mode that can be provoked either voluntary or non-voluntary with electrical stimulations. So in a way, when you wake up and we are interviewing these people, they are able to extend this kind of supercomputer modeling assets and getting the feedback towards our model to understand whether we need to add more entities in the model and with the computer-assisted support to generate potential relations. That further, we are able to extend also with the morphological entities. And because we speak about different scenarios, adding also things like cyber terrorism, cyber wars, hybrid wars, 5G wars, we have different scenarios, and this is one of our latest surveys that is addressing our computer-assisted exercise that was being organized last month with another university in Bulgaria. And it's addressing smart cards and smart drones in a hybrid environment that is actually giving another projection towards the future in an interactive manner, not just being a passive observer, but also being an active participant in the process of hacking, being a red team, on the process of protecting, being blue team, and also in the process of analysis, being a white team. This is just an illustration about some measurements related to the human factor involved on both from an export and gaming perspective. And with different modalities, as I said, both on central and peripheral nervous systems, also about response time with the stimulation beam, and also about voice dynamics related to your emotional presence. And finally, we also continue, and also today that is one of the main reasons I have to stay in Sofia with this event, young researchers, that continues both today and tomorrow. And they are developing projects about the future and improbable virtual realities during different periods of the year, both in the winter and in the summer. And with their assistance, we are able to, in a way, verify the future guess of our experts community. So at the end, I would like to again stress about this initiative that we are developing since 2017, and also within this initiative, my friend Igor Franz and me signed a joint agreement on the e-students association, and especially Serbia is on the board. And we have more than 6 countries now, and with this really significant number that we hope to extend to 17 within the next year, we will publish already digitally, and I'm going to send you maybe next week to Professor Romazet the digital copy of our book, Digital Transformation in the Post-Informational Age, which is actually an update since the publication in 2019, just before the pandemic. We have picked a bunch of more than 6 countries authors in the topic. I'd like to invite you within the next that will going to appear after maybe 3 years now. But before this, I'd like to wrap up with this discussion that technology is innovation, that are entering our new ecosystem and bodies, both physically and with the cognitive level, are actually establishing, as I said at the very beginning, a new hyperactivities that can be from philosophical perspective named the metaverse, just like the name of the metaverse that is being trying to be established within Mark Zuckerberg and Facebook environment, but is actually philosophical ideas behind. And within this new metaverse, one's program is to involve in the proper way the machine's intelligence, trying to, in a way, both advance our knowledge and promote it, but not to admit the idea of cyber attacks inspired in the Skynet scenario from the sci-fi movies. And so discussing about this in order to build a new informational society after this knowledge processing and establishment with the machine intelligence, and to assure a resilient society, we need a multilateral understanding that is actually joining both human and machine intelligence, hopefully in a more proper way. I'd like to thank you for the attention and to stress that more focused things that are in the book will be given by my PhD student Stefan Daffman, addressing some of the new challenges about ransomware and artificial intelligence. So thank you for your attention.
Thank you so much, Professor Rincher. It's always a pleasure to have you here. And well, I'll ask first, are there any questions from the live audience? Perhaps? Are there any questions from the audience on the Zoom call? Okay, if not, I'll just ask a quick question. You said that I saw that in the last slides that you're very involved, that your students are very involved in this digital societies, and it's very nice to have the young people involved. I wanted to ask how much are they enthusiastic about participating and learning about their rights, their obligations in a digital world nowadays compared to, for instance, maybe 10 or 20 or even more years ago when it comes to young people?
So, you know, thank you for the question, Romania. So I'd like to share that tomorrow is actually the session that is addressing especially the informatics project. So there we have a hybrid one in mathematics and informatics. But my impression is that it's very difficult for them to judge the role of the technologies, whether positive or not. So here I read something that gives them ambiguities, like to show the generalization in works. But for them, they don't like the matrix form because the artificial intelligence actually keeps the control, and at the same time, they like very much the innovation. So you see shallow interaction between people and technologies. Artificial intelligence will be more positive for the social interactions. Ambiguity in the reality and in between human-machinery interactions and relations. So in the future, they expect future avatars, like movies in the Blade Runner, will be reality, not just an example. But at the same time, more amusing world, and things will look better than they are. So this is also some positives. And necessity to get also real life experience, because you know nowadays the social networks like Realme, for example, are trying to address us in another way. But as a result of our psychological and mental stuff that are in the book, I would like to share that the Z generation and Alpha generations are getting other problems. This one are not that young, actually 16 to 18 years. But for them, they try to get more fast than the technology, so they get ambiguities with their speech about their behavior, trying to keep the pace of the technologies. And also, they are in a way alienated or otherwise safe from our generation. For them, the smart devices are actually something normal because they are born with the device. And luckily, the gaming consoles, the distributed realities, Google are still on the way, but maybe in 10 years, the new generation will be stuck there. So the biggest challenge for the media future, the next 10, 5 years, will be exactly this technological innovation that no one is able to control. And there is no issue about the ethics and the effects about us. And especially when you go to weaponize the system by means of your mental health and by means of your behavior, things like violence in the social reality inspired by the technologies are already quite visible. And this is not just in a way isolated cases, but more kind of a set by behavior that is even fashionable later. This is something to worry very much about. For them, hacktivism, sneaking around certain profiles is a question of honesty, dignity, and knowledge. And this is one of the biggest problems about securing the future cyber world, but to get the right knowledge about activities results. It's our generalization impression. Thank you very much.
Okay. So nowadays, everybody is talking about the cybersecurity risks that are in the future, about how the products are going to be designated or defended. As we're talking about cybersecurity, in every second that we're thinking about it, it's big cyber attacks are happening all around the world. But the future is not only about making the virus, making the firewall system much intelligent. It's about having the bigger weapon and the bigger technologies, the future technologies. We're working with machine learning, we're using decision trees, we're using neural networks for our studies and for our experiments. But this is the let's say the university part, this is the academic part. Many people around the world are also teaching themselves how to use artificial intelligence, machine learning to deal with big data problems, deal with standard everyday problems using the scheduling, workflow, and tasks. But the cyber criminals are also learning very much and very quick about how to deal with much more hard and sustainable cyber attacks, which cannot be detected or neutralized by the cybersecurity softwares and solutions. So many of the cyber attacks nowadays, as we're talking about ransomware attacks, are using standard type approach, such as let's say scanning the entire computer system or server system, capturing the internet traffic for future, let's say, phishing attacks, or even stealing data. Mainly the ransomware attacks are targeting in your data, so they can corrupt your data, encrypt it by using the standard AES-256 algorithm, which is one of the most popular and, let's say, fast for encrypting data. Over our research, I found, me and my team with Professor Minchev, found that mainly the most ransomware attacks are targeting the file key header, which is the part of the file that is giving the instructions to file work. Like where the part is the entire file, the date of the file, the libraries that is connected with, the types of mechanisms to unlock it and use it, because many of the files have encryption layer in their cells. As a problem, like let's say with databases, with keys, with backup data, and so on. But here, by using file key encryption is the fastest way, because if you encrypt the entire file, it's going to take much more time, because we have files that are bigger than 50 megabytes, 1 gigabyte and more, and this is going to be needed much more time to deal with. But by encrypting the header encryption, the file header, you're going to get the same result, encrypted data, and you can do this like in 2 or 5 minutes for entire computer system, which is much easier. So here I have a demonstration about, visual demonstration about the simple file key header encryption. As we here see, we have the DOS header, DOS anti-headers with the file picture, signature, the file header, optional header if you have libraries and so on. And we have the section table, which is the code and the data inside our file. As we damage this part of the file, we get unreadable data that is having no kind of understanding. On the only way it's data and returning it back normal operation mode is pay the ransom. And if you have look, you may receive the encryptor. But as we're talking about the cybersecurity and the ransomware, they're continuously evolving. Mainly the ransomware attack and let's say the malware attacks are targeting your system, your data. But what if the ransomware attack, as we detected over our honeypot networks, two types of ransomware attacks that are using approaches with machine learning. I built in a laboratory systems environment ransomware, let's say, for the first time it's not ransomware, it's just the program, which is collecting data about your movement around the system, about how your security system works, and exchanging this data with the ransomware machine learning, going over network places like you have some data server which is remotely you may use, or you can use on your networks, you can use even a hosting system as a web hosting. You may collect training data and store it there for future attacks. By this way, the ransomware attacks are going to evolve by using this type of learning procedures, because most of the antivirus systems, the security systems, are using approaches with deep learning, deep NLP, machine learning, neural networks to perform better with the scanning detection, get big scores by detecting unknown and even known threats. And it doesn't depend on if they're sophisticated or not. They're using this type of models so they can predict the future event, the future technology, the future degeneration of the ransomware attack, or even the malware attacks, or even the cyber attacks. But here we're talking about the ransomware that is capable of learning itself how to disable, how to turn off your security system. Doesn't matter is it going to use the security system, going to use machine learning to detect malware, because most of the testing examples that I've done with, let's say, 10 security systems, they doesn't detect any of these programs, which is collecting data, how it works, what kind of file it uses, what kind of libraries it's using in the cell, and how it's using its resources by, let's say, memory encryption, sharing memory, because many of the security companies have technology called shared memory or byte communication between the processes, because they have multiple processes running on background. And this activity is monitored as the antivirus monitors your activity and the virus activities by the attack, by the process that is developed to analyze and find a gap between the security system that you're using. So here we have system security monitor. This is the part of the system that is protecting our system. This is the cybersecurity software. We have our system monitor, internet activity monitor, and user activity monitor. So after the virus is infecting your system, I'm using Windows for my testing environment. That's why I'm using .exe file, executable file. The ransomware detection method and silence machine learning is trying to make, after collecting data, connection to the remote control center. And by making this connection, it's trained model. So in future, if the control center give the attack, give the file, give the process instruction to destruct or to, let's say, sniffing data or kidnapping data, or even stealing your credentials by using normal simple keylogger. By using models that are going to disable your security software, it's making your security obsolete. It's not going to work anymore. Here we have 6 types of detections. We have deep learning, machine learning, pattern matching, the most common types of detections, behavior detection, signature, and honeypot. So here we have the infection waves, which are more than 200. We have undetected, which are less than 50. We have detected, which are less than 20. And we have cured that are mainly 0, because the antivirus companies cannot detect this type of threat. the infections ratio is going to get higher in the future, and we also have the machines, because we're using 10 machines in our calculations. That's why you may see the machine state is not moving. After even making a big, let's say, network, it's using the way that the botnet network is working. The network and the machines in this virus type is going to get higher and higher. So the virus can collect more and more data about your daily basis, about your work, about your entire structure of working. Doesn't matter, are you in the corporate room, are you in your office, are you in your home office, or you're working from your tablet or phone. These type of threats are actually out there already, and they're targeting multiple people, multiple devices, IoT, phones, and computers. But nowadays, these type of threats are so intelligent because they're in the base study, the base level of, let's say, perform the better way of learning and make decisions how to shut down your system or how to shut down or even exploit your firewall infrastructure. So that's why now we have the cloud-native decentralized network, which is the way that our virus is, if it's detected by the security software and deleted, neutralized by it, it's collecting all of this data and sending to others' computers, the other infected systems that are in this botnet network. If you may want, you can add a server, which is going to be the main part of collecting and storing this data for future analyzing and training set for your virus, or you may share with other hosts, other victims all around the network. That doesn't mean that you're in closed network, like local network. This virus can work World Wide Web. So this makes it very dangerous, and the future is, let's say, hurtful for the many computer systems and for the cybersecurity industry. Because as I told, the hackers are also starting to using AI and machine learning technologies that are going to help them with making the better, faster type of attacks that are undetectable. In the years behind, we heard about homomorphism, the way that the virus can change its structure so the antivirus company, the antivirus algorithm cannot detect it. That's why here, let me find it. That's why here I tested with deep learning, machine learning, pattern matching, behavior detection, signature method. Every these type of detection method are absolutely against this type of attack. Many of the let's say deep learning and machine learning algorithms I'm using developed by myself applications that are going to detect this type of ransomware are getting notified by its activity, but there is no kind of evidence that this activity is malicious because you don't have malicious actions. So the software may see that this type of process is collecting data, training itself, making communications all around the web, sending data, even if the cybersecurity solution is capable of hijack the connection and capture all of the data and read the data. It's only just the metadata for training sets, which is harmless to your system. But the problem is when you get the virus, let's say when you target the virus to make itself like a Trojan horse, like a worm, like a ransomware attack. And this is the scariest part because this ransomware attack is now intelligent. It's collecting data, let's say over the time, days, weeks, years. And when it's fully, or let's say the right level of attacking, it may interface with government agency, may get inside to critical data structures with servers and military operation centers, and activate itself by remote control. Even if you don't have the remote control center, this type of attacks can be learned, like the flame virus, like the Stuxnet, to be activated non-remotely by a human factor. which is making this attack hybrid, because on one way you can control the attack over the internet, on other you may, let's say, infect person device, and this person doesn't have the right policies, or doesn't use the policy of not using its, let's say, personal activities like hard drives, USB devices, and so on his workspace. The organization could be much more vulnerable. Doesn't depend on it's connected to the network or not. So in the future, the smart reality is related to needs of technological sector, and technologies are going to evolving much faster, and much more type of knowledge is going to be needed to deal with the cybersecurity attacks. As we are talking at this moment, there are many cyber attacks going all around the world. Many banking systems are targeted by cyber criminals, even children's or even government organizations. And without getting the right priority, without getting the right technologies, the best technologies for their time, the cyber attacks are going to rule the entire web over the future. So imagine if you have cyber attack that is capable of learning itself, not only about how to deal with your security software, but deal to infiltrate in systems that are connected with the healthcare technologies. You may, let's say, you may interfere with the human life that is on the medical attention at this moment, because we have this type of Internet of Things technologies that are used to control respiratory systems, blood clearing systems. And if this type of virus want to attack, want to, let's say, populate its activity and make it visible, it can kill people in the future. As we see in about 1-2 weeks ago, even Tesla have a problem with their AI. So as you may know, they're having a coincidence with high speed that the car wasn't controllable by the person. So this is the first step of making this type of attack. Okay, let's say we can say that this is just a normal event that is some kind of bug in the system and the software. But this type of bugs in the future, let's say a year or two, are going to be something normal. And if there are no, let's say, intelligent security solutions that are capable of detecting intelligent ransomware attacks or malware attacks, the future is going to be catastrophic for the cybersecurity industry and for the information technologies. Let's say Terminator, Skynet, and so on. Thank you for your attention.
Good afternoon. My name is Dusan, and I will tell you something about cybersecurity criteria through a fuzzy approach. Here you can see the authors, as Professor Nemanja said, Professor Nenad Vesic, Branislav Vranjelovic, and Georgije Vujadinovic. Let me just put. In the introduction, we will tell something about information, the rapid development of IoT, cloud computing, data transfer, and the increasing the number of exploitable vulnerabilities. This is the reason why we wrote this paper, and the methodology we decided to use is the multi-criteria decision making, especially using the fuzzy AHP based on triangular fuzzy numbers. Let me say a couple of main things about TFNs. As you can see, this is the definition of triangular fuzzy number, and here it's the membership function. It's usual writing of it. When you see the number and tilde over it, it will be the triangular fuzzy number, and if those boundaries L, M, and U are equal, we should talk about usual crisp numbers. Here are the basic stuff about triangular fuzzy numbers, its operations, binary and unary operation. Now we have this based on me A tilde and its inverse me A tilde to the power of -1 from the left and from the right side. And those two combined give us this. It's the total integral value, which we use casting it later in methodology in the declassification part. We have lambda equals 1, 0.5, and 0, as it was usual, and two more, 0.25 and 0.75, which we introduced in the recent paper. It will help the decision maker to have better and precise decisions. Now we will tell something about a couple of phases in the fuzzy AHP. First part is to establish the hierarchical structure, the main goal top, and later criteria and sub-criteria, and if it's so defined, the alternatives at the end. Then we have matrix comparison. It will be the matrix, let's call it D, with n type times n, with a lot of n over 2, or n times 1 divided by 2 comparisons in all, from higher to all lower levels. When two criteria are the same, or on the main diagonal, we will have 1, 1, 1 as a triple. And here you can see the triangular fuzzy numbers, their inverses, and in the left column, what they really mean. It's usual. This scale could be different, but we decided to use this one. Now, maybe I shall return. You can see the distance between 1 and 3. Here the distance is 2. At this one the distance is 1. Then we have again 2 and 1 and so on. It was done in the paper written by Sergeyevich and Medeiros from 2008, when they say that fuzzy distance of 2 or odd values should be applied. Also in order to have better consistency. For other scales, see. Now, those triangular fuzzy numbers could be represented just to have graphical representation. Now, phase 3 is to check if those matrices are consistent. This is really important, and if it's not, the matrix is not consistent, the decision makers should rewrite their decisions. We use CI and CR, called consistency index and consistency ratio, and lambda max, I think we all know from linear algebra, is the maximal eigenvalue. Then we use the RE from this table. We decided to write from 3 to 10 and stop to 10, because for 1 and 2 the RI is equal 0. The CR should be less than 0.1 or 10%. If it's not, the problem is again for decision makers to write their decisions in a better way. Now we have the falsification phase. Here you can see how we apply the triangular fuzzy numbers and its inverse. They are common operations, and we have the value of synthetic extent used by Chen from 96. This is how we have S tildes. Now we have to go to other phase and to defuzzify those fuzzy numbers. This is the total integral value. It's just one of the possibilities for defuzzification. After that, we normalize the results, dividing each weight vector by the sum of the vectors from its column, just to ensure that we have numbers from 0 to 1, and at the end we should rank criteria, sub-criteria, alternatives, everything we decide to do. After that, we shall say that the authors talked to the professor from the computer science department of our university and tell something about these criteria and sub-criteria. We decided to divide them into two parts: private data misuse and harming system itself. And with methodology, we obtained the weights for each of the criteria and sub-criteria. They should be written here, or for instance, maybe I should write and tell you first this. Here you can see all of them ranked. At the end, you can see X11 to X14. They are sub-criteria from the first group, and 21, 24 sub-criteria from the second group. Here you can see their rank, and it's obviously that X11 is the most important. It's data password leak. After that, we see that X12 has the greatest value, greater in the fuzzy than in the regular AHP case. That's good to know and to compare. In our later papers, we will use also lambda 0.25 and 0.75 to have a better consistency. And here we can obtain a lot of results. The second time S is reserved for X12, and after that, as you can see here, those are results from the first group for AHP and all three cases for fuzzy case. Those are obtained matrices. And here we see the results. Here are for X1 0.66 and for X2 0.33, because we said that X1 group is the most important one. After that, here we see the weights for all other sub-criteria related to the second group. X21 is the DOS detection, as the value 0.47 in the AHP case, and median value in fuzzy case is 0.447. You see that these values do not diverge, they are convergent and really similar to each one. At the end of all sub-criteria and all cases with a little bit greatest value in the regular AHP in the fuzzy case lies the H24, its anomaly detection. In this case, we will continue our research and add some other criteria, maybe dividing them into 3 or 4 groups. So it could be a little bit better result. Those matrices are obtained using given methodology. They are all consistent, which you could check here in the bracket. We gave the CR. It will be all, and thank you for your attention.
Thank you, Dusan. Are there any questions from the live or from the audience online?
So if I may ask a question about the fuzzy sets implementation, Dusan. So did you try different fuzzy sets granulations to get better accuracy, or you just tried this approach to get more robust algorithm approach?
For this case, we used only triangular fuzzy numbers. Trapezoidals are applicable, but we decided to use them maybe later. And we have Pythagorean and spherical fuzzy numbers. Also, they could be used in the spherical fuzzy AHP.
Thank you. Because in general, fuzzy sets are good as a robust method when you work with lots of noisy data. So that's why I was asking. I like your.
Thank you. If you have criteria which you could rank to obtain their fuzzy weights or just crisp weights, call. We can rank
Completely agree. The question is how to get the numbers working.
Yeah, numbers with the science behind that.
Exactly. Thank you.
Yes.
And with this, we will close the conference, and I would like to thank all the participants and all the authors of the papers, and see you all again next year.